What if everything you believe about time is off the mark? Recent science hints that time, a constant, unyielding flow, might be nothing more than a trick of perception. In this exploration, we'll venture from time's philosophical beginnings to its intricate roles in physics and quantum mechanics. We'll review historical concepts, break down our everyday encounters with time, and look at the latest discoveries that challenge our current views. As we dig into the connection between time and space, the idea of time as an illusion starts to make sense, influencing both our lives and how we see the world. Join us as uncover insights that could reshape our understanding of the past, present, and future. Imagine waking up every morning to a world where the past, present, and future are not fixed points, but rather fluid moments dancing in a vast ocean of possibilities. This idea challenges our traditional understanding of time. What if time is not a straight line but a complex illusion that we create to navigate our experiences? Many scientists and philosophers suggest that time, as we perceive it, might be a construct of our minds, a way for us to organize our lives and memories, rather than an absolute truth of the universe. As we embark on this journey into the depths of time itself, prepare to explore a world where minutes and hours stretch and fold in ways that defy our everyday understanding. Challenging our conventional understanding of time begins with questioning its linear nature. Most of us view time like a straight line, moving from the past through the present and into the future. However, scientific exploration unveils a more complex picture. Instead of a single path, time can be perceived as a fabric, woven with interrelated threads that can stretch and compress based on various factors, such as speed and gravity. One way to explore this idea is by considering how time behaves differently in various situations. For instance, when we travel at very high speeds, close to the speed of light, time itself appears to slow down for us compared to someone who remains at rest. This means that if you were to journey through space at incredible speeds, you could return home and discover that more time has passed for those who stayed behind. This suggests that our experience of time is not fixed and can vary greatly depending on our circumstances. Additionally, we can delve into concepts like time loops or cyclic time, where time might not progress in a simple forward direction at all. Imagine a scenario where time could circle back on itself, allowing moments to repeat or overlap. Such ideas shake the foundation of what we thought we knew, indicating that time might be a more flexible dimension than we imagine. By exploring these perspectives and connecting them with the latest scientific discoveries, we begin to unlock a richer, more intricate understanding of time. This journey leads us to consider larger questions about reality itself, inviting us not just to observe time, but to actively engage with its mysteries and implications. Time is a fundamental aspect of our existence, intricately woven into the fabric of our daily lives. It provides structure, helping us organize our days and plan activities. Imagine waking up in the morning without a clock or any sense of time. Chaos would likely ensue, as people would struggle to coordinate work, meals, and interactions. Our reliance on time originates from the consistent rhythms of nature. The sun rises and sets at predictable intervals, marking day and night. The changing seasons follow a pattern that helps us prepare for various conditions throughout the year. As a result, we have developed calendars and clocks to quantify these natural cycles, creating a shared understanding of time among people. Culturally, societies have created rituals and milestones anchored in time, reinforcing its significance in human interactions. Events like birthdays, holidays, and anniversaries carry meaning because they occur at specific points in time, allowing us to celebrate, reflect, or plan for the future. Moreover, our fast-paced world reinforces the importance of time management. In a society driven by productivity, people often feel the pressure to optimize their time, whether for work or personal pursuits. This creates a shared language around time, with phrases like "time is money" emphasizing its value. On a deeper level, time influences our perception of life itself. It affects how we experience moments, creating memories and shaping our understanding of change and growth. As we move through life, we feel the weight of time, not just as a passing series of moments, but as a fundamental part of being human. It frames our existence, influencing priorities, aspirations, and connections with others. Time plays a crucial role in shaping how we experience the world around us. It serves as a framework, organizing our daily lives and helping us understand events in relation to one another. Picture a movie. Time is what allows the story to unfold in a sequence, leading us through emotions and experiences. Without time, everything would feel chaotic and unanchored. Our brains are wired to perceive moments as a continuous flow, where one event leads to another. This progression enables us to learn from history, anticipate the future, and make decisions based on past experiences. We use time to create memories, influencing how we recall our lives and the events we've encountered. Interestingly, different cultures can perceive time differently. In some societies, time is seen as linear, like an arrow flying forward, while in others, it may be viewed as cyclical, repeating in seasons and traditions. This diversity influences how people plan, celebrate, and interact with one another. Moreover, scientific discoveries reveal that the flow of time can be altered. Near strong gravitational fields, such as those created by massive stars or black holes, time moves differently. This means that for someone close to such an object, time might pass more slowly compared to someone far away. Thus, time doesn't just influence our perception, it also becomes a factor in the very fabric of reality, shaping experiences in ways we are still striving to understand. Through these varying dimensions and interpretations, time remains a fundamental part of our existence, intricately weaving the narrative of our lives. Time has always played a crucial role in shaping human understanding and the development of societies. At its most basic level, time allows us to perceive the sequence of events, helping us understand cause and effect. This fundamental concept has guided cultures in creating calendars, marking significant moments and structuring daily life. As early as ancient civilizations, such as the Egyptians and the Mayans, people studied the movements of the sun and stars to track time, establishing systems that influenced agriculture, religious practices, and daily routines. As societies evolved, so did the complexity of their understanding of time. Philosophers pondered questions about the nature of time, proposing different theories about its flow and significance. In many cultures, time was seen as cyclical, reflecting the natural rhythms of the seasons and life itself. Conversely, in the modern era, particularly with the advent of scientific exploration, time began to be perceived as linear, moving steadily forward. This shift helped fuel advancements in technology, industry, and communication, ultimately revolutionizing how we view our place in the universe. The Industrial Revolution marked a significant turning point as the mechanization of timekeeping transformed societies. Clocks became central to daily life, coordinating activities and enabling people to work in unison. This newfound precision affected social structures, promoting productivity and efficiency, while also introducing new challenges, such as the stress of time management in people's lives. Moreover, the scientific exploration of time, particularly in the 20th century with the theory of relativity, deepened our understanding of time as not just a constant, but as something influenced by speed and gravity. These revelations shifted perspectives within both science and philosophy, sparking debates about the nature of reality and our perception of existence. Throughout history, the role of time has been woven into the fabric of human experience, guiding everything from agricultural practices to technological innovation and shaping our philosophical inquiries. Ultimately, our understanding of time continues to evolve as we uncover more about the universe and our place within it, reminding us that time is not just a measure, but an integral part of the human journey. Time is a fundamental part of our understanding of the universe, but various scientific theories challenge the way we perceive it. One prominent idea comes from physics, particularly the theory of relativity proposed by Albert Einstein. According to this theory, time is not absolute. It can change depending on speed and gravity. Imagine a clock ticking slowly on a spacecraft traveling very fast compared to a clock on Earth. This suggests that time is more like a flexible fabric, bending and stretching rather than a fixed, unchanging line. Another compelling concept is found in quantum mechanics. At the smallest scales of matter, time doesn't always behave in a linear fashion. Some interpretations of quantum theory imply that events can occur out of sync, adding to the idea that our traditional understanding of time may be an illusion. Picture a series of frames in a film where scenes jump around instead of following a logical order. This challenges the notion that the past, present, and future are distinctly separate periods. Additionally, there are philosophical discussions around the concept of the block universe. In this view, all points in time, past, present, and future, exist simultaneously, much like a completed sculpture rather than a moving film. This raises intriguing questions about free will and causality, suggesting that what we perceive as the flow of time may simply be our limited perspective of an already existing reality. Together, these theories open up a fascinating dialogue about the true nature of time, prompting us to reconsider how we understand our place in the universe. Rather than being a straightforward experience, time is a complex and multifaceted concept, inviting both scientific inquiry and philosophical reflection. Scientists often refer to time as an illusion to highlight how our understanding of it can differ from its underlying reality. In our daily lives, we perceive time as a linear progression, moments passing one after another, marked by events and changes. This sequential view of time, where past, present, and future seem distinct, is a comfortable way to organize our experiences. However, in the realms of physics, especially when we look closely at theories like relativity, time becomes much more complex. According to these theories, time is not a fixed backdrop against which events unfold. Instead, it can be affected by speed and gravity. For instance, as an object moves closer to the speed of light, time for that object appears to slow down relative to someone who is at rest. This phenomenon suggests that time is not universal. It can stretch and compress based on the conditions of the environment and the observer's perspective. Moreover, in the context of quantum mechanics, time can become even more elusive. Some interpretations propose that time may not exist as a fundamental aspect of the universe at all, but rather is an emergent feature arising from more basic interactions between particles. So, when scientists say time is an illusion, they are encouraging us to reconsider our intuitive understanding of it. They imply that our perception of a flowing, linear time may not fully capture the intricate, interconnected fabric of the universe, where moments are less tangible and more subjective. This invites us to explore deeper questions about the nature of reality and how we experience it. Quantum physics shifts our understanding of time in profound ways. Traditionally, time has been viewed as a consistent flow, an unchanging backdrop against which events unfold in a linear sequence, past, present, and future. However, quantum physics introduces a different perspective that challenges this notion. At the quantum level, particles can exist in multiple states at once. This is often illustrated through the concept of superposition, where a particle can be in several locations or conditions simultaneously until it is measured or observed. This leads to the idea that the act of observation itself may influence the outcome, which hints that time may not be as straightforward as we assume. Events do not unfold along a simple timeline. Instead, the very act of measuring can change how and when those events are realized. Moreover, quantum entanglement reveals that particles can become linked, such that the state of one particle affects another, no matter how far apart they are. This instantaneous connection appears to disregard the restrictions of time and space, suggesting that information can be shared in ways that defy our traditional temporal logic. Also, the concept of time itself in quantum mechanics is not an absolute measure. It can behave differently depending on the context, and different observers may perceive time in varying ways based on their relative motion or position. This means that in the quantum realm, time can become more fluid, disjointed, or even non-linear, making it less of a steady path and more of a series of possibilities. Ultimately, these challenges posed by quantum physics prompt a re-evaluation of time itself. It can be seen as a multifaceted concept rather than a simple, uniform experience. This new understanding encourages us to explore the nature of reality itself, where time and existence are intricately woven into the fabric of the universe. Relativity theory fundamentally changes our perception of time, introducing the idea that it is not a fixed, simple flow as we commonly think. Instead, Albert Einstein's theory suggests that time is intertwined with space into a single fabric known as spacetime. Imagine spacetime as a flexible mat that can bend and stretch due to the presence of mass. When an object with significant mass, such as a planet or a star, sits on this mat, it creates a noticeable dip or curve. This gravitational effect influences how time is experienced in different locations. For instance, the closer you are to a massive object, the slower time appears to pass relative to someone situated further away. This means that a clock on a satellite in space can tick at a different rate than a clock on Earth, showcasing how time can stretch and compress based on gravitational fields. Furthermore, relativity also introduces the concept of relative motion. When two observers are moving relative to one another, each may measure time differently. This might seem counterintuitive, but it demonstrates that time can be experienced variably depending on one's speed and gravity's influence. Thus, rather than being a universal constant, time becomes a personal experience shaped by the forces of gravity and motion. It teaches us that the flow of time is much more complex than it appears. Each moment exists not as a singular point, but as part of a vast, dynamic interplay between the observer and the cosmos. At the cosmic level, scientists observe some truly surprising phenomena regarding time, particularly how it behaves differently depending on where you are and what you are experiencing. One of the most fascinating phenomena is time dilation, which occurs due to the effects of gravity and speed. When an object moves at speeds close to that of light, or when it is in a strong gravitational field, time begins to slow down compared to areas where gravity is weaker or where motion is minimal. Imagine spending a year aboard a spaceship traveling near the speed of light. For the astronauts on board, just 1 year might pass, but when they return to Earth, they could find that many more years have gone by there. This idea demonstrates that time is not fixed, but rather can stretch or contract based on various factors. Another remarkable effect is found near black holes, where time behaves even more unexpectedly. As one approaches the event horizon, the boundary beyond which nothing can escape a black hole's gravity, time slows down dramatically. For an observer far away from the black hole, it would appear that the clock of someone falling in ticks more and more slowly until it seems to freeze. This leads to the intriguing notion that across the universe, different observers may experience time in fundamentally different ways, highlighting the complexity of our understanding of time itself. Additionally, cosmic events like gravitational waves, which occur due to massive objects accelerating in space, also carry fascinating implications for time. These waves create ripples in the fabric of space-time, and their detection allows scientists to study how the universe itself is changing and evolving, which provides insights into the very nature of time in a dynamic setting. Together, these phenomena reveal that time is not merely a uniform progression, but a complex tapestry woven into the fabric of the universe, shaped by speed, gravity, and the intricate dance of cosmic events. Throughout history, philosophers have approached the nature of time in diverse and intriguing ways, reflecting their broader views on reality. In ancient times, thinkers like Heraclitus suggested that time was a constant flow, a river where nothing remained the same, emphasizing change as an essential aspect of existence. This idea presents time as a dynamic force, suggesting our experiences and surroundings are in perpetual motion. Contrasting this, Parmenides argued that time is an illusion, promoting the notion that change and time do not truly exist. For him, reality is unchanging and timeless, leading to debates about whether our perceptions of time are merely constructs of the mind. As philosophy progressed, figures like Aristotle took a more practical approach, suggesting that time is a measure of change, related to the movement of objects. He proposed that we experience time through the events that unfold around us, organized in a sequence of past, present, and future. This view laid early foundations for later theories of time as a structure that orders our experiences. Moving into the modern era, thinkers like Immanuel Kant introduced the idea that time is not an external reality, but rather a framework through which humans understand the world. He argued that time is a way our minds organize experiences, implying that our perception of time is shaped by our consciousness. The debate continued into the 20th century with existentialist philosophers like Martin Heidegger, who explored time as essential to existence itself. He described it as a dimension that encapsulates our experiences, highlighting how our understanding of time is intertwined with our sense of being. These philosophical perspectives illuminate how profoundly time is woven into our understanding of existence identity, and the universe. The ways they grappled with time reveal not only their insights into the concept itself, but also reflect their views on humanity's place within the cosmos. Understanding this historical tapestry enriches our appreciation of time as an elusive yet essential aspect of life. Immanuel Kant, a pivotal figure in philosophy, offered ideas that have profoundly influenced the way we understand concepts such as time. His viewpoint suggests that time is not an absolute entity that exists independently of us, but rather a framework through which we perceive our experiences. To Kant, our minds actively shape our understanding of reality, and this includes how we perceive time. Kant argued that time is one of our innate categories of understanding. This means we do not learn about time from the outside world. Instead, it is part of the way our minds organize experiences. For example, when we recall past events or anticipate future ones, it is our mental processes that arrange these memories and expectations within a temporal sequence. Without our mind to structure it, events would not have a sense of past, present, or future. Kant also believed that while we experience time as linear, it might not reflect the true nature of reality. He pointed out that because our perception of time is subjective, our understanding could be limited. This aligns with the idea that time is, in many ways, an illusion created by our minds to help us navigate the world. Furthermore, his thoughts harmonize with modern scientific insights, such as those from physics, which suggest that what we understand as time might not have the straightforward, unchanging quality we assume. The interplay between our consciousness and the universe raises questions about whether time exists independently or is just a convenient way for humans to explain their experiences. Kant supports the notion that time is more of a mental construct rather than an isolated, objective reality. His contributions challenge us to think about how our perceptions shape not just our understanding of time, but the very fabric of our experiences. Eastern philosophy offers a unique perspective on the nature of time, often suggesting that our perception of it is not as straightforward as we might think. In many Eastern traditions, such as Buddhism and Hinduism, there is a belief that time is cyclical rather than linear. This idea contrasts with the Western view, which typically sees time as a path moving from the past through the present and into the future. In the cyclical view, time is often related to natural cycles, like the changing of the seasons or the life cycle of birth, growth, decay, and rebirth. This concept posits that events are interconnected, and the past, present, and future exist in a continuous flow. It challenges the notion of time as a fixed measurement and suggests instead that moments are fleeting, constantly transforming, and ultimately illusory. Additionally, in mindfulness practices rooted in Eastern philosophies, there is an emphasis on being present in the moment. This focus draws attention away from concerns about the past and future, advocating for an awareness that transcends conventional time. By anchoring oneself in the present, practitioners come to understand that the relentless pursuit of time can lead to stress and anxiety, while true peace can be found in the now. Furthermore, the concept of Maya in Hindu philosophy describes the world as an illusion, suggesting that our attachment to time and events prevents us from seeing the underlying reality. This perspective encourages individuals to recognize that their experiences of past and future may not reflect their true selves or the nature of existence. Through these frameworks, Eastern philosophy invites us to reconsider time as a less rigid concept, encouraging a deeper understanding that transcends mere measurement, ultimately suggesting that clinging to time may limit our experience of reality. This idea can profoundly alter our relationship with our lives, opening pathways to a more flexible understanding of existence itself. Perceptions of time vary significantly across cultures, with two primary ways of understanding it being linear and cyclical. In linear perceptions, often found in many Western cultures, time is viewed as a straight line moving from the past through the present and into the future. This perspective emphasizes progress and achievement, suggesting that events happen in a sequence that builds on one another. Newer generations are seen to create advancements, leading to the belief that the future will always be better than the past. In contrast, cyclical perceptions, common in many indigenous cultures and in some philosophies like Hinduism and Buddhism, understand time as a repeating cycle. Here, events are viewed as part of an eternal loop. Life, death, and rebirth are seen not as endpoints but as phases within a larger cycle. This view places importance on the rhythms of nature, seasons, and agricultural cycles, suggesting that every ending is not truly an end, but rather a transition into another phase of existence. These differing perceptions also influence how cultures approach concepts like history and change. Linear cultures may focus on historical milestones, viewing progress as essential, while cyclical cultures might emphasize continuity, tradition, and the lessons learned from past cycles. Thus, each perception shapes not only personal experiences, but also community relationships, spirituality, and how future generations are envisioned within the timeline of existence. Ancient civilizations had unique approaches to understanding time, which can still resonate in today's scientific discussions. For instance, many early societies like the Mayans and Egyptians used celestial events such as the movement of the sun, moon, and stars to structure their calendars and daily life. They observed these patterns meticulously and developed systems that reflected their agricultural cycles and religious beliefs. This deep connection between celestial rhythms and human activities showcases an early recognition of nature's timing. In contemporary science, these ancient concepts of time challenge and enrich our understanding of physics. For example, scientists now recognize that time isn't a fixed entity. It can vary based on speed and gravity, as shown in Einstein's theory of relativity. This fluid concept of time echoes the cyclical perception held by many ancient cultures, which saw time as a series of repeating patterns rather than a straight line. Moreover, an exploration of ancient timekeeping technologies like sundials or water clocks brings forward discussions about precision in measuring time. The accuracy of these early instruments laid the groundwork for our modern understanding of timekeeping, with atomic clocks today allowing us to measure time with incredible precision. These connections remind us that science is often built on historical foundations, and examining how ancient cultures viewed time can provide valuable perspectives in current debates, particularly in areas like cosmology and the nature of the universe. As we investigate phenomena such as black holes or the expansion of the universe, we still grapple with questions about time that ancient thinkers contemplated long ago. By weaving their ideas into modern science, we gain both historical insight and a broader understanding of complex concepts that shape our view of reality. Our brains perceive time in a fascinating and complex way, influencing how we experience every moment of our lives. Picture time as a flowing stream, where our conscious awareness acts like a boat navigating along the water. We use various cues to understand the passing of time. One critical aspect is our sensory experiences, such as the sights and sounds around us. Each moment feels different based on how we engage with these surroundings. When we are happy, for instance, time tends to feel like it is flying by, while moments of boredom can stretch on endlessly. This phenomenon happens due to the way our brain processes information. The more details and emotions we experience, the richer the memories we create, making time seem faster during events full of significance. Moreover, our internal body clock, also known as the circadian rhythm, plays a big role in how we perceive time throughout the day. This natural cycle helps regulate our sleep patterns, energy levels, and alertness. As we age, our perception of time can change as well. Many people say that time seems to speed up with age, possibly because new experiences become less frequent. Our brain also multitasks when processing time. It monitors events, our attention levels, and the rhythm of our surroundings, helping us maintain an understanding of past, present, and future. By weaving together these intricate threads of perception, our brain creates a stream of time that feels continuous, allowing us to navigate through life's experiences with fluidity and coherence. Memory plays a crucial role in how we experience and perceive time. Think of time as a series of events, much like a continuous stream. Our brains capture moments and store them in memory, allowing us to recall them later. When we think back on our experiences, those memories can shape how we perceive the length and passage of time. For instance, during exciting or busy moments, our brains often take in more information and form many memories. Later, when we reflect, those events seem to stretch out, making that time feel longer than it actually was. On the other hand, during mundane or repetitive experiences, The brain may not create as many distinct memories. In this case, those moments may blur together, causing time to feel as though it has passed quickly. Furthermore, our emotional state significantly influences this memory process. High-stress events, which often create vivid memories, might feel prolonged when we recall them because of the intensity of our experiences. This phenomenon occurs because our brains are highly engaged during positive experiences, creating vivid memories that make time seem to speed up. Conversely, during moments of stress, fear, or sadness, time can stretch infinitely. Think about a tense situation like waiting for important news or enduring a scary moment. Our focus narrows, and every second can feel like an eternity. This is partly due to the brain's heightened awareness of surroundings and events, processing more details in those intense moments. When we look back, it feels as if time expanded because our brains recorded so much information in that short span. Additionally, extreme emotions can lead to a sense of time distortion in both directions. Heightened emotional states might cause a person to lose track of time entirely, either completely engrossed in an activity or overwhelmed by anxiety. This capacity to alter our sense of time demonstrates just how intimately our minds and feelings are linked. Ultimately, emotional experiences create a fluid relationship with time, altering our perceptions in ways that can leave a lasting impact on how we remember both fleeting and significant moments. To understand the relativity of time perception, we can draw from everyday experiences. One analogy involves two siblings. Picture one sibling preparing for a long road trip while the other stays home. During the trip, the traveling sibling may feel like time passes slowly, consumed by anticipation and excitement for the adventure. Meanwhile, the sibling at home may experience time racing by as they remain busy with daily activities. Both siblings are experiencing time, but their emotional states and activities significantly affect how they perceive its passage. Another powerful story is that of astronauts aboard the International Space Station. They orbit Earth at high speeds and experience shorter days than we do on the ground. Because they are moving so quickly, time for them actually ticks away slightly different compared to those of us on Earth. When they return after spending months in space, they find that their clocks tell a different tale compared to what their loved ones experienced back on the ground. They arrive back having aged less than those who stayed on Earth, illustrating how motion alters the very flow of time. Additionally, think about how intense experiences, like a thrilling roller coaster ride, can feel like they last forever, while a simple hour spent waiting for an appointment can feel fleeting. This disparity arises from the brain's processing of information. When we are alert and engaged, our brains take in more details, making time feel elongated. Conversely, during monotonous periods, our minds might gloss over minutes and hours, making them seem to rush. These examples highlight that time is not just a ticking clock, but a flexible experience shaped by emotions, activity, and perspectives. Real-life stories illustrate that time is not merely a constant, but a rich tapestry woven from our lives and experiences. Modern technology has drastically changed how we experience time in many ways. Think about the smartphones that millions carry in their pockets. These devices keep us connected and offer instant information, which can make a moment feel shorter. If you need to know something, you don't have to wait. Answers are just a few taps away. This constant connection creates a sense of urgency, making time seem to fly by as we move from one task to the next. Then, consider social media. Platforms allow us to share moments in real time, again altering our perception. Events that once required days or weeks to plan can now change in an instant. It enhances our sense of immediacy, where waiting feels obsolete. This can lead to a feeling of a faster-paced life, where the days seem to blend together as we scroll through endless updates. Technology also affects how we organize our time. Online calendars and task management tools help us plan our days more effectively, but this can create a paradox. While we become more efficient, we also fill our schedules to the brim, leaving less room for relaxation. This efficiency paradox can lead to a cycle where time feels compressed, making every hour seem packed with activities. Further, the way we consume entertainment has shifted dramatically. Streaming services offer entire seasons of shows all at once, prompting viewers to binge-watch rather than wait for episodes to release weekly. This contributes to a culture where patience is less practiced and time spent waiting is minimized. All these changes lead to a unique and complex relationship with time. While technology offers countless efficiencies, it also introduces a pace that challenges our ability to savor moments. As we adapt, our experience of time becomes a blend of speed and overwhelm, a dance between being endlessly connected and yearning for meaningful pauses. The idea of space-time reshapes how we understand both space and time, merging them into a single framework. Traditionally, we think of time as a separate dimension that flows continuously, much like a straight line. In contrast, space-time brings together the three dimensions of space with the fourth dimension of time into one unified concept. In this combined model, events are described by their position in both space and time. Imagine that time is like a river where moments flow in one direction. When we introduce space into this picture, that river no longer flows alone. Instead, it runs through a landscape made of three-dimensional space. This interconnection means that how we perceive time can change based on our movement and the influence of gravity. For example, when an object moves very fast or is near something very massive, the way time passes for that object can differ from how it passes for someone far away. To the person moving swiftly, their time feels normal, but an outside observer might notice their clock ticking slower. This effect is a direct result of space-time curving around massive objects, and it highlights that time is not an unchanging constant. By understanding space-time, we see that time can stretch or compress, depending on speed and gravity, effectively blurring the lines we once believed existed. This intertwining reveals a universe far more complex than we once thought, changing our perceptions of everything from daily life to the vast cosmos. In discussions about time, some theories propose that the present moment acts as a unique focal point, suggesting that our experience of time might be an illusion. Imagine time as a river, flowing from the past through the present and into the future. If we consider the present moment, it is that brief point on the river where we experience life directly. Theories arguing that time is an illusion often emphasize that the past is a memory and the future is a projection, both of which exist only in our minds. This leads to the idea that what we perceive as the present is merely a fleeting moment, constantly slipping into the past. Instead of seeing the past, present, and future as a continuous stream, these theories posit that only the present is real and experienced. Philosophers and scientists interested in this concept suggest that what we understand as time might not have an independent existence outside of our perception. Instead, it's our consciousness that strings together individual moments, creating the illusion of a flow. This perspective invites us to rethink how we understand existence and reality, urging us to consider whether the present moment is the only constant in a universe where everything else is in flux. In this view, the present moment holds a special significance, acting as the only part of time that we can interact with directly, while the past and future remain hypothetical constructs. Time dilation introduces a fascinating twist to how we perceive time itself. Generally, we think of time as a constant flow, a uniform tick of the clock that governs our daily lives. However, time dilation reveals that this notion is only partially accurate. As our speed increases, especially when approaching the speed of light, time behaves differently for diverse observers. Imagine two twins. One stays on Earth, while the other travels in a high-speed spaceship into space. From the perspective of the twin in the spaceship, time moves normally. But to the twin on Earth, it appears as though the traveling twin is moving slower. When the space traveler returns, they would have aged less than their Earth-bound sibling. This effect is not just theoretical. It has been confirmed by many experiments, such as those using atomic clocks on fast-moving jets. This concept challenges our understanding by suggesting that time is not an absolute constant shared by all. Instead, it bends and stretches based on factors like speed and gravity. Close to a massive object like a planet or star, time also runs slower due to its gravitational field. This means that time can vary even over relatively short distances depending on gravitational influence. Ultimately, time dilation illustrates that our experiences of time can differ significantly based on our motion and the forces acting around us. This realization shifts our perspective from seeing time as a fixed measure to understanding it as something flexible and relative, deeply intertwined with the fabric of space itself. The study of black holes offers profound insights into the nature of time itself. black holes represent regions of space where gravity is so intense that nothing, not even light, can escape their grasp. This incredible gravitational pull does more than warp space. It alters the very fabric of time. Imagine a strong magnet bending metal to its will. Similarly, a black hole warps the flow of time around it. For an observer standing far away from the black hole, time passes normally. However, as one approaches a black hole, the effects become increasingly pronounced. Near the event horizon, which is the boundary beyond which nothing can return, time operates at a different pace. To someone falling toward a black hole, time seems to slow down relative to the outside world. This phenomenon is called gravitational time dilation. It suggests that time is not as fixed as we might think. Instead, it is influenced by gravity and the structure of space. When studying black holes, scientists gain insights into how these extreme conditions challenge our conventional understanding of time. Furthermore, the behavior of black holes can help explain theories of time that go beyond traditional notions. Some theories in physics propose that time may not flow in a linear manner. Events can be interconnected in ways that challenge our perception of past, present, and future. By understanding the complex interactions around black holes, researchers may unlock clues about the fundamental nature of reality and how time itself might weave into the universe's tapestry. Particle physics experiments challenge our traditional understanding of time in remarkable ways. These experiments involve studying the smallest building blocks of matter, like protons and electrons. In doing so, physicists often work with incredibly high energies, where the effects of relativity come into play. When particles are accelerated to speeds close to that of light, they experience time differently than we do. For a particle moving extremely fast, time literally slows down. This phenomenon, which can seem mind-bending, occurs because, according to the theory of relativity, the perception of time is linked to speed. Clocks carried by these fast-moving particles tick more slowly when observed from a stationary point of view. Essentially, while a moving particle may experience one moment, an outside observer sees that same moment stretched out across a longer duration. Furthermore, in particle collisions, scientists can create conditions that resemble those just after the Big Bang. In such moments, our notions of cause and effect can break down. Particles emerge and disappear in ways that seem to happen instantaneously, suggesting a complex interplay where past and future blur together. These interactions provide insights into the very nature of time itself, revealing layers of reality that we are only beginning to comprehend. By pushing the boundaries in particle physics, researchers not only deepen our understanding of fundamental particles, but also provoke questions about the very fabric of time. They invite us to reconsider how we perceive the passage of time and the interconnectedness of events on a cosmic scale. Quantum entanglement and superposition are fascinating aspects of quantum mechanics that challenge our traditional understanding of time and reality. To grasp their connection to the perception of time, let's break it down simply. Superposition describes the ability of a quantum particle to exist in multiple states at once. Imagine a spinning coin that can show heads or tails, but while it spins, it represents both possibilities simultaneously. It only decides on a single state when we stop it and observe it. This principle implies that particles can be in a state of potential until they are measured, raising questions about the nature of reality and time. In a sense, time can feel different in the quantum realm, as actions only become defined at the moment of observation. Entanglement takes this idea a step further. When two particles become entangled, they remain connected no matter the distance between them. Changing the state of one particle instantly affects the other, even if they are light years apart. This phenomenon suggests a kind of instantaneous communication that defies our typical linear understanding of time, where events seem to unfold sequentially. When we combine these concepts, we see that time may not flow uniformly at the quantum level. Just as entangled particles can respond to each other regardless of distance, events may not be strictly bound by the timeline as we perceive it. The connection between entanglement, superposition, and time invites scientists to reevaluate the very fabric of reality, suggesting that our understanding of time could be more complex and deeply interwoven with the workings of the universe than we have previously imagined. The uncertainty principle tells us that there is a limit to how precisely we can know certain pairs of properties about a particle, like its position and momentum at the same time. To illustrate, think of trying to measure a tiny, buzzing bee. The more accurately you pinpoint the bee's location in your garden, the less certain you can be about how fast it is flying or in which direction it is headed. This principle reveals a fundamental aspect of nature. The very act of measuring one property affects another. When we apply the concept of uncertainty to time, it suggests that our ability to predict future events is inherently limited. Imagine trying to predict not just where the bee will be in a moment, but also how fast it will move. The more focus we place on its current position, the fuzzier our understanding of its future movement becomes. In the realm of quantum mechanics, this uncertainty is a normal part of how particles behave. It implies that time itself cannot be completely predictable on the smallest scales. Instead, it reveals a fundamental randomness in nature. This unpredictability doesn't mean that events are entirely chaotic. There are still patterns and statistical rules that guide how things behave over time. However, the specifics of individual events remain shrouded in uncertainty. As we explore deeper into the cosmos and the nature of time, we find that what seems stable and orderly may actually hold inherent unpredictability at its core. Quantum theories offer fascinating insights into the nature of time at incredibly tiny scales. In classical physics, we think of time as a steady, unchanging flow, similar to a river that moves in one direction, from the past to the future. However, things look very different when we delve into the quantum realm, where particles and their behaviors operate under unexpected rules. At the micro level, particles do not behave like solid, stable objects. They can exist in multiple states at once, almost like they are blurred in and out of reality. This introduces a strange relationship with time. Some quantum theories suggest that at this scale, time may not be the continuous ribbon we're used to, but rather a more fragmented, broken experience. In such models, what we perceive as time might emerge from a more fundamental layer of reality, one where conventional notions do not hold. One idea is that small quantum particles can be interconnected, communicating instantaneously across distances. This connection can lead to time behaving differently, almost like a web rather than a straight line. Furthermore, some theories hint that time could dissolve entirely when dealing with quantum states, becoming a product of something deeper, such as the fundamental interactions between particles. As researchers explore these concepts, they are not just rethinking time, but also how we understand the fabric of reality itself. What's captivating is that these ideas challenge our sense of cause and effect, where an event leads to another. In the fringe of quantum mechanics, this relationship may not always be as clear-cut as we believe, suggesting that perhaps at very small scales, the concept of time could be entirely different from our everyday experiences. Quantum mechanics reveals a universe that behaves very differently from our everyday experiences. In this strange realm, the concept of time isn't fixed. Instead, it behaves more like a series of snapshots rather than a continuous stream. Imagine if every moment in time were like a picture in a photo album. In quantum mechanics, the precise timing of events can vary and depend on the observer's perspective. When we try to pinpoint the present moment, we encounter a problem. There is no single universal now. Different observers can perceive time differently, depending on their speed and position in relation to one another. This idea can be compared to watching a movie with multiple cameras. Each camera captures its own view at its own pace. In quantum mechanics, particles exist in a superposition, a state of being in multiple places or conditions at once, until we measure them. This introduces uncertainty about their specific location or timing, causing time to lose its straightforward flow. Consequently, the notion of one universal present moment becomes tricky, as each observer might be viewing their own now, influenced by the actions and positions of other observers. This interplay suggests a universe teeming with complexity where time can be relative, leading to situations where events that seem simultaneous to one observer may not appear that way to another. Thus, quantum mechanics challenges the idea of a synchronized existence, presenting a view of reality where what we consider the present moment may actually exist in diverse forms across the cosmos. In the world of quantum mechanics, experiments have revealed some truly astonishing behaviors of time, reshaping our understanding of reality. One notable experiment is the delayed choice experiment. This experiment challenges our intuition about cause and effect. In a typical setup, particles like photons are sent through a beam splitter where they can take one of two paths. Remarkably, when scientists decide to make a measurement after the particle has passed through the splitter, they can affect how the particle behaves as if it had never been measured at all. This raises profound questions about whether an action taken in the present can influence the past. Another fascinating illustration comes from the phenomenon known as quantum entanglement. Here, particles become interconnected in such a way that the state of one instantaneously affects the state of another, regardless of the distance between them. Scientists have shown that this interaction happens faster than light could travel, suggesting a bizarre aspect of time where the usual rules don't seem to apply. It hints at a deeper connection within the universe, where information can transcend the limitations of space and traditional time frames. Additionally, the concept of time in quantum mechanics plays a crucial role in experiments involving superposition, where particles exist in multiple states at once until observed. When a particle is not measured, it possesses a kind of indefinite existence that is both here and there, leading us to ponder the nature of time itself. The act of measurement seems to collapse these possibilities into a single definite state. The implications of this are groundbreaking, indicating that perhaps the flow of time is not as linear and fixed as we once thought. Through these experiments, we are slowly uncovering the mysterious dance of time in the quantum realm, reshaping our fundamental grasp of the universe. String theory presents a fascinating perspective on the nature of the universe, and it offers intriguing insights into our understanding of time. Traditionally, we view time as a continuous flow, much like a river that takes us from the past into the future. However, string theory, which proposes that the fundamental building blocks of the universe are tiny vibrating strings, suggests a more complex picture. In string theory, time is not a fixed universal backdrop against which events occur. Instead, it could be seen more like a dimension intertwined with the fabric of space. This notion aligns with the idea that time may not be as absolute as we once thought. For instance, in the context of a multi-dimensional universe, there might be different ways to experience time depending on the specific conditions and dimensions in which you exist. This concept challenges the traditional view of time as a simple, linear experience. Additionally, the theory raises questions about the past and future. If the fundamental nature of reality is a series of interconnected strings vibrating in various modes, then the separation of time into distinct past, present, and future may also be an illusion. This suggests that all moments could exist simultaneously at different frequencies of vibration, akin to a musical chord where every note blends together, creating a single cohesive sound. This perspective invites us to reconsider our intuitive understanding of time. Instead of viewing it merely as an ongoing sequence of events, we might see it as a more complex structure influenced by the underlying principles of string theory. While string theory is still evolving and remains largely theoretical, it encourages us to explore the possibility that time, as we know it, might not be the unchanging linear journey we have always assumed. Instead, it could potentially reflect a deeper, more intricate reality, where the illusion of time shapes our perceptions of existence. The multiverse theory proposes that our universe is just one of many, possibly an infinite number, existing simultaneously. Imagine standing in a vast library filled with countless books. Each book represents a different universe, complete with its own set of physical laws, constants, and histories. In some of these universes, events in our own may have unfolded differently, leading to entirely distinct realities. This idea affects our understanding of time in intriguing ways. In the traditional view, time is linear, moving forward in a single direction and leading to one unique reality. However, within the multiverse concept, every decision or event could create a branching pattern of time. Each choice can lead to different paths, akin to the way a tree grows branches. Some branches may mirror our own timeline closely, while others veer off dramatically, exploring alternate outcomes. This perspective invites us to reconsider concepts of causality and progression. If multiple timelines exist, then every moment could be just one of many possibilities. Instead of viewing time as a strict singular flow, it becomes a complex web of interconnections, where every instant holds the potential for diverging realities. Thus, rather than a straightforward passage, time could be seen as an intricate puzzle, filled with countless scenarios and outcomes, each subtly reflecting the choices made within different versions of the multiverse. Scientists model time travel scenarios using theories from physics, particularly the concepts of relativity and quantum mechanics. Imagine time as a flowing river, where each moment is a point along its path. According to Einstein's theory of relativity, time is not fixed. It can stretch and bend around massive objects like stars or black holes. In these scenarios, scientists explore the idea of moving through time by manipulating these distortions in space. One of the most famous models involves something called a closed time-like curve, which suggests a path through space and time that loops back on itself. This idea allows for the possibility that a traveler could return to an earlier point in time. While captivating, it raises complex paradoxes. A classic example is the grandfather paradox, which poses the question, what if someone traveled back in time and prevented their own grandfather from meeting their grandmother? This would create a situation where the time traveler could never have been born, leading to a contradiction. Another intriguing scenario involves multiple timelines or alternate realities. If a time traveler were to change something significant in the past, instead of erasing their original timeline, it might split into different branches, creating a new timeline that coexists with the original. This concept offers a way to escape some paradoxes, but introduces its own complexities, such as questions about the nature of identity and causality. Through these models, scientists delve into the intricate relationship between time and existence. While we have not yet found a way to time travel, these scenarios challenge our understanding of the universe and elevate scientific curiosity. They remind us that the fabric of time is still one of the great mysteries waiting to be unraveled. Symmetry is a fundamental concept in physics and has a fascinating relationship with time. To understand this, think of symmetry as balance or equality in nature's laws. For instance, if you take a picture of a beautiful landscape, it looks the same whether you view it from the left or the right. This balance often reflects how certain physical processes behave consistently over time. In terms of time, symmetry suggests that certain physical laws operate the same, whether you look at the past or the future. This idea is called time symmetry. When the rules of physics don't change, we perceive the flow of time as smooth and continuous. However, when systems break this symmetry, like when a glass shatters, it generates more disorder, a phenomenon known as entropy. The flow of time feels like it moves forward as we tend to observe change and disorder increasing in the universe. Now let's consider the reversal of time. If you could rewind the universe back to its earlier state, ideally, everything would look the same in a perfectly symmetrical world. But the reality is different. While the equations governing motion are typically the same, whether in the past or future, the universe prefers to head towards states with higher disorder, making the reversal feel unnatural. So, symmetry provides a foundational frame for understanding time's behavior. It illuminates why we perceive time as unidirectional, flowing toward the future. Despite the intricate nature of physical laws, this symmetry gives us a way to explore the many mysteries surrounding time itself. Space and time are intricately linked in what scientists refer to as the fabric of space-time. This concept suggests that the three dimensions of space do not exist separately from the one dimension of time. Instead, they form a single, continuous entity. Imagine space-time as a flexible sheet. When objects with mass, like planets or stars, are placed on this sheet, they create wrinkles or curves. These curves affect how other objects move through this combined space and time. Theoretically, Albert Einstein's theory of relativity revolutionized our understanding of this connection. It tells us that the presence of mass bends space-time, which leads to the phenomenon of gravity. This means that something as simple as the Earth orbiting the Sun is not just about distance, it's also about the impact of time. When astronauts travel at very high speeds or spend time in strong gravitational fields, they actually experience time differently compared to those on Earth. Observably, scientists confirm this connection through experiments, such as observing clocks. High-speed satellites traveling around Earth tick at a slightly different rate than clocks on the ground. This shows that their relationship with gravity and their speed changes the flow of time. Additionally, light, which is a crucial messenger in the universe, travels through space but is also affected by the curvature of space-time. As light passes near a massive body, it bends, an effect known as gravitational lensing, which further solidifies our understanding of how space and time interact. The relationship between space and time is foundational to understanding how the universe operates, affecting everything from the orbits of planets to the very nature of reality itself. If we start to view time as an illusion, it challenges our fundamental understanding of how we live our lives. Traditionally, we see time as a strict sequence of past, present, and future events, guiding our actions and shaping our experiences. Recognizing time as a construct could lead us to rethink how we approach life's moments. Imagine your daily schedule, hours marked for work, leisure, and rest. If time were seen as less rigid, we might feel less pressure to adhere strictly to these divisions. This could open the door to a more fluid way of living, where we might find joy in the present without the constant worry of what's next. Tasks could become less about completing them within a time frame and more about engaging with them meaningfully. Additionally, relationships could flourish if we let go of the notion that time is running out. We often rush through interactions with friends or family, focused on the next appointment. Acknowledging time's potential as an illusion might encourage deeper connections, as we'd prioritize quality of engagement over the clock ticking away. In a broader sense, this perspective could instill a sense of freedom. We might adopt a mindset that allows us to appreciate experiences without the weight of time constraints. Instead of always striving for future goals, we could find satisfaction in simply being present, embracing each moment as it comes. Ultimately, questioning the nature of time could transform not only our personal priorities, but also societal structures, as we rethink productivity, success, and how we measure journeys and achievements. This shift could lead to a more holistic approach to living, where happiness is found in presence rather than in the relentless pursuit of future milestones. The perspective gained from exploring space can significantly influence fields like medicine and psychology. When we think about the vastness of the universe, we start to understand how small we are and how interconnected life can be. This broader outlook can change how we approach health and well-being. In medicine, insights from space exploration can lead to advancements in technology and techniques. For instance, studying how the human body responds to the challenges of microgravity during space missions has helped researchers understand muscle wasting and bone density loss. These findings can translate into improved treatments for aging and bedridden patients on Earth. Moreover, the need for reliable medical technology in space can inspire innovations that enhance emergency care, diagnostics, and surgical procedures back home. In psychology, the perspective gained from contemplating the stars reminds us of our shared human experience. Being aware of a broader context can foster a sense of unity, encouraging mental health professionals to adopt holistic treatment approaches that emphasize well-being on both individual and societal levels. The isolation astronauts' experience in space also offers valuable lessons about stress management and coping strategies, which can inform therapeutic practices for people dealing with loneliness or anxiety in their everyday lives. Additionally, facing the unknown in space can help us better understand our own fears and resilience. When researchers study how people cope in extreme environments, they uncover techniques that might help individuals handle personal challenges. Therefore, the quest to understand space not only expands our knowledge of the universe, but also enriches our approaches to health and mental wellness here on Earth. The concept that time may be an illusion opens up fascinating possibilities for creativity and innovation. When we think of time as a rigid structure governing our actions and thoughts, it can limit the scope of our imagination. However, if we view time as fluid and subjective, suddenly, the doors to creativity swing wide open. Imagine a world where past, present, and future are interconnected rather than linear. This perspective allows individuals to draw inspiration not only from their current experiences, but also from memories and the endless possibilities of what could come next. Artists, scientists, and inventors benefit from this mindset by blending ideas from different times, merging what has been learned with what has yet to be discovered. In such a reality, innovation flourishes. Visionaries might consider earlier concepts as canvas and blend them with modern insights, creating something entirely unexpected. This free-flowing understanding of time encourages experimentation without the fear of failure, as each attempt is seen not as a lost effort, but but as a step toward an unlimited array of possibilities. Moreover, time's perceived limitations can often lead to pressure, which might stifle creativity. When we release ourselves from this constraint and embrace the idea of time as an illusion, we can allow our minds to wander freely, sparking new ideas and unique projects. In this way, the belief that time isn't a fixed entity can truly unleash the full potential of human creativity and innovation, driving progress in ways we have yet to imagine. Understanding time has profound implications for technological advancements. At its core, time is a fundamental part of our universe, influencing everything from communication to travel. Insights into the nature of time could lead to innovations in how we manage energy and information. For instance, if scientists further unravel the mysteries of time dilation, an effect where time moves differently under various conditions, it could inspire new methods for timekeeping and synchronization, essential for everything from GPS to telecommunications. Moreover, if we gain a deeper grasp of the relationship between time and gravity, we might develop technologies that utilize these principles in practical ways. Picture advancements in transportation, like vehicles that could potentially harness gravitational forces to travel faster or more efficiently. In theoretical applications, we could also dream of exploring concepts like time manipulation, although this remains in the realm of science fiction for now. Additionally, enhancing our understanding of time could significantly impact computing. Quantum technologies, which already rely on the peculiar behaviors of particles, could find new algorithms and processes influenced by time's mysterious properties. This could lead to faster and more powerful computers, revolutionizing the fields of artificial intelligence, data processing, and beyond. In fields like medicine, a deeper understanding of time might influence how we perceive developmental stages in biology, potentially leading to breakthroughs in treatment protocols and enhancing the ways we approach aging and health. Essentially, as we decode the complexities of time, we might not just advance existing technologies, but also open doors to entirely new fields where our current understanding seems limited. Every advancement hinges on how effectively we can translate these complex ideas into accessible tools and practices that improve our daily lives. The exploration and understanding of space have profound implications for how we address environmental and economic challenges on Earth. As we look to the stars, we can draw valuable lessons from how life thrives in extreme conditions and utilize new technologies that space exploration fosters. Space missions often require innovative solutions for resource management, energy generation, and waste recycling. These advancements, when adapted for use on Earth, can lead to more sustainable practices in various industries. For instance, the development of closed-loop systems used in spacecraft, where water and oxygen are recycled efficiently, could inspire similar systems on Earth. This approach not only conserves resources, but also minimizes waste. Moreover, the push for renewable energy solutions in powering spacecraft can accelerate shifts toward cleaner energy sources back home, reducing our dependence on fossil fuels. Economically, the growing space industry presents new markets and job opportunities. Investing in space technologies leads to advancements in telecommunications, medicine, and materials science, creating a ripple effect in the job market. These technologies can enhance productivity across various sectors, driving economic growth while also considering environmental impacts. Furthermore, understanding how planets and ecosystems function beyond Earth informs our knowledge of climate change. By studying other celestial bodies, scientists can apply insights to better predict and mitigate environmental shifts on our planet. Overall, as we harness the knowledge and technologies developed through space exploration, we can tackle the pressing environmental and economic challenges of today with innovative, sustainable solutions. The question of whether time is an illusion has sparked much debate among scientists. One prominent argument against the notion of time being an illusion comes from the realm of physics, particularly through the lens of relativity. Albert Einstein's theory shows that time is intricately linked to space, forming what is known as spacetime. This means that time behaves in a measurable and consistent way, depending on the observer's relative speed and position. For instance, when someone travels at very high speeds, they experience time differently compared to someone who remains stationary. This variation indicates that time is a real dimension rather than a mere illusion. Additionally, physicists point to the second law of thermodynamics as a key argument. This law states that in a closed system, the overall disorder or entropy tends to increase over time. This progression towards greater disorder creates a clear direction of time, often referred to as the arrow of time. Because we consistently observe this phenomenon in our daily lives, from the way ice melts to how a cup shatters, many scientists argue that this evidence supports the notion of time being a tangible aspect of our universe. Furthermore, neuroscientists contribute to this discussion through their studies of how we perceive time. It is understood that the human brain processes experiences and memories in a way that constructs our understanding of time's passage. This cognitive aspect reinforces the idea that time, while perhaps subjective in how we experience it, is guided by external measurable factors. While some theories propose that time can be viewed as an illusion, significant arguments from physics, thermodynamics, and neuroscience present a strong case for time being an essential and real dimension of our universe. These perspectives reveal that time is not merely what we sense, but rather something integral to the fabric of reality itself. The understanding of time is a complex topic that draws in both physicists and philosophers, each offering unique perspectives. Physicists explore time through the lens of science, investigating how it works within the framework of the universe. They study phenomena like time dilation, which occurs under the influence of gravity or speed, showing that time can pass at different rates depending on one's location or state of motion. This scientific view views time as a measurable quantity, integral to the laws of physics that govern how we perceive the universe. On the other hand, philosophers delve into the nature of time itself, questioning its existence and significance. Is time a fundamental part of reality, or is it merely a construct of human perception? Philosophers ponder concepts such as whether the past, present, and future exist simultaneously, or if time is linear. These debates often lead to discussions about free will, existence, and the meaning of change, further enriching the dialogue surrounding time. When physicists and philosophers engage in these debates, they greatly influence each other's understanding. For instance, a physicist's discoveries might prompt philosophers to reconsider their views on time, while philosophical inquiries might inspire physicists to explore new areas of research. This interplay creates a deeper, more nuanced understanding of time, bridging empirical evidence with profound implications about what time means to our experience of reality. Each perspective adds a layer of insight, transforming time from a simple measure into a multidimensional concept that shapes our understanding of the universe and our place within it. Throughout history, several groundbreaking experiments have challenged our understanding of time, reshaping how we perceive it. One of the earliest influential shifts came with Albert Einstein's theory of relativity. This body of work proposed that time is not a constant. Instead, it can stretch and contract depending on speed and gravity. His famous thought experiment involving a train illustrates this idea. To a passenger on the train moving fast, the time keeps ticking normally, but to an observer on the ground, time appears to go slower for the train's passenger. This discrepancy suggests that time is affected by motion and context. Further questioning arose from high-speed particle experiments. Scientists have created particles called muons, which can exist longer when they're moving close to the speed of light compared to when they are at rest. This finding complements the idea that time is experienced differently depending on motion, providing direct evidence of time dilation predicted by relativity. Another pivotal domain is quantum mechanics. In experiments involving entangled particles where two particles are linked and instantaneously affect one another regardless of distance, questions arise about the nature of time. Does action precede time, or does it merely flow in one direction as perceived? This puzzling behavior has led physicists to explore the relationship between time and information, suggesting that perhaps time as we know it might be an emergent quality rather than a fundamental aspect of the universe. Lastly, advancements in technology have led to the precise measurement of time, showcasing phenomena like gravitational time dilation. Clocks on satellites in orbit actually tick slightly faster than those on Earth due to the difference in gravitational pull. This observation has practical applications, such as in global positioning systems, emphasizing that even everyday technology relies on the nuanced understanding of time. Together, these studies and experiments reveal that time is not simply a steady stream, It is a complex, dynamic feature of our universe, shaped by speed, gravity, and even the realms of subatomic particles. The nature of time has long been a topic of intense debate among scientists, philosophers, and thinkers. Different interpretations about what time truly is can lead to contrasting opinions that fuel controversy. On one side, some scientists view time as a linear progression, a continuous stream where events flow from the past through the present and into the future. This is the view that aligns with our everyday experience of cause and effect, where one event leads to another in a seemingly straightforward manner. Conversely, there are those who challenge this perception. They propose that time might not be as straightforward as it appears. For instance, in the realm of theoretical physics, some theories suggest that all moments, past, present, and future, exist simultaneously, much like a photograph containing multiple events captured in a single instant. This idea can feel abstract and challenging because it contrasts sharply with our intuitive understanding of life as a series of moments unfolding sequentially. Moreover, the implications of these differing views extend beyond philosophical musings. They influence fundamental concepts in physics, particularly in relation to theories about the universe. For example, Einstein's theory of relativity reveals that time can change depending on speed and gravity, introducing the idea that it is not a constant but rather malleable. This scientific revelation raises questions about the essence of time itself and whether it should be treated as a physical entity or simply a human-made concept to make sense of our experiences. As researchers share findings and theories, these contrasting views can create friction within the scientific community, driving debates that often reach the public. People become fascinated by questions around the very fabric of reality itself. Is time real? Is it something we perceive or something that exists independently of us? These questions challenge our understanding and shape how we interact with the world, making the discourse around time a vivid and ongoing exploration that captivates minds across disciplines. Unpopular or fringe theories, while often dismissed in mainstream discussions, can play a crucial role in advancing our understanding of science. They push boundaries by challenging established ideas, prompting scientists and researchers to re-evaluate what is accepted as true. When a fringe theory arises, it often sparks curiosity and debate. This questioning is essential in any scientific field, as it can lead to new hypotheses that may eventually be tested and refined through experimentation. Moreover, these unconventional ideas can inspire innovative approaches to problem solving. By thinking outside the box, researchers may discover alternative pathways or entirely new lines of inquiry. For instance, concepts once ridiculed or considered far-fetched could provide valuable insights or even serendipitous discoveries if they lead to fresh perspectives on existing evidence. Additionally, fringe theories can ignite public interest in science, drawing attention to lesser-known phenomena and inviting conversations that might not have happened otherwise. This engagement can encourage educational initiatives, stimulate collaboration among scientists from different disciplines, and ultimately foster a culture of open-minded exploration. The discourse around these theories serves as an important reminder that scientific progress often requires a willingness to entertain ideas that may initially seem improbable or unorthodox. Personal stories about time often reveal profound changes in how individuals perceive their lives and experiences. For example, consider someone who has faced a life-threatening illness. The initial shock of the diagnosis can shift their understanding of time from a routine flow to an urgent treasure. Each moment becomes more precious, leading them to focus on what truly matters: relationships, passions, and unfulfilled dreams. They may embrace spontaneity, choosing to spend time with loved ones, taking adventures, or pursuing a long-held desire to travel. This contrast between taking time for granted and suddenly seeing its fragility can reshape their entire outlook. Similarly, when someone experiences the birth of a child, their perception of time can shift dramatically. The endless days of waiting transform into fleeting moments of joy as they watch their child grow. Each stage feels both slow and fast, where hours spent in sleepless nights are followed by startling milestones that seem to arrive in the blink of an eye. This journey often teaches them to savor the small, everyday experiences, as these moments can hold great significance amidst the busyness of life. Another compelling narrative arises from individuals who have traveled extensively. Discovering diverse cultures can alter their relationship with time altogether. In some cultures, time is seen as fluid, an open canvas where schedules are more flexible and life unfolds without rushing. Returning home, these travelers might begin to prioritize connection over productivity, valuing the quality of their interactions above the clock's demands. These personal tales reflect a universal truth. Transformative moments in our lives can fundamentally alter how we perceive time, pushing us to reconsider what we value and how we choose to spend our days. They remind us that time is not just a measure of our existence, it is woven into the fabric of our memories and relationships, ultimately shaping our purpose. The notion of time being an illusion often sparks diverse debates, especially when personal experiences come into play. On one hand, people frequently share anecdotes that suggest time flows differently based on their emotional state. For instance, moments of intense joy or fear can feel like they last forever, while a routine day might seem to zoom past. These subjective perceptions indicate that time might not be experienced uniformly, lending some support to the idea that time could be more of a mental construct rather than a fixed reality. Conversely, many argue against this perspective by highlighting how time governs our lives. Events in nature, such as the changing of seasons or the life cycle of a plant, adhere to a consistent progression that can be measured and observed. This regularity provides a foundation that contrasts with the more subjective, personal experiences of time. Additionally, stories of near-death experiences often involve individuals reporting a sense of timelessness, where they perceive life events as occurring simultaneously. Such experiences challenge the conventional understanding of time, suggesting that personal consciousness might transcend the linear timeline typical in daily life. Yet these personal accounts coexist with the broader scientific approach to time, which portrays it as a continuous, measurable quantity grounded in physics. Individual anecdotes illustrate the complexity of time, showing how it is felt differently depending on circumstances and inner feelings. At the same time, they exist alongside a structured external reality that holds time as a dependable component of life. This interplay of personal experience and universal observation enriches the discourse on whether time is indeed an illusion or a fundamental aspect of our universe. Mindfulness and meditation practices can significantly change how we perceive the passage of time. When engaged in these activities, people often experience a state of deep focus and awareness. This concentrated state can make moments feel elongated, as they become fully absorbed in the present. Imagine sitting quietly and noticing your breath or the sounds around you. As you do this, distractions fade away and time seems to stretch. In contrast, during everyday activities filled with stress or multitasking, hours can feel like they fly by. This occurs because our minds are scattered, and we often rush through experiences without truly engaging with them. Mindfulness pulls attention back to the here and now, creating a richer experience where time feels more expansive. Neuroscientific studies suggest that meditation can also influence how the brain processes time. Regular practice can enhance connectivity in parts of the brain related to awareness, memory, and emotions, ultimately leading to a more profound sense of presence and potentially altering our internal clock. As practitioners become more familiar with slowing down their thoughts, they may develop a deeper appreciation for time itself, finding joy in every moment rather than just racing through life. This perspective shift can lead to a heightened sense of fulfillment and less anxiety about the future, allowing individuals to cultivate a healthier relationship with time. Human experiences that challenge our understanding of time often arise from moments of profound change, loss, or wonder. Think about the feelings associated with watching a loved one age or facing difficult goodbyes. These situations can create a sensation where time seems to stretch or compress, making us acutely aware of every passing moment. When we are immersed in extraordinary events, such as witnessing a breathtaking sunrise or the vastness of a starry sky, we can feel a connection to the universe that transcends our ordinary understanding of time. Such experiences can create a sense of timelessness, where hours may feel like mere minutes, leaving us in awe of life's fleeting nature. Similarly, moments of intense concentration or joy, like achieving a long-desired goal or being deeply engaged in a creative act, can cause time to slip away without notice. This kind of experience reminds us that time is not merely a ticking clock, but something we perceive uniquely in relation to our emotions and actions. As we navigate through these experiences, we often find ourselves contemplating the future, a past that seems to fade, and an ever-present now filled with possibilities. These reflections can lead to realizations about life's impermanence, inspiring not just a deeper appreciation for the moments we have, but also a longing to make the most of the time we are given. Art and literature have a unique ability to delve into the complexities of time, presenting a rich canvas for exploring its mysteries. Through storytelling and visual representation, these mediums capture the fluidity of our experiences and emotions tied to time. A novel may unfold in a non-linear fashion, jumping between past and present, forcing readers to engage with the idea that memories and moments can coexist, shaping our understanding of who we are. Visual artists often use symbolism to represent time's passage. A painting featuring a sunset can evoke a sense of endings and the inevitability of change, reminding us that each day leads to night and that time is inherently fleeting. Similarly, the use of clocks or hourglasses in artwork can symbolize the relentless ticking away of moments, prompting viewers to reflect on their own relationship with time. Poetry, on the other hand, can condense feelings about time into powerful imagery and emotion. The use of metaphors can illustrate how time feels strained, stretched, or even cyclical. By capturing a fleeting moment in a few words, poets invite us to contemplate the fleeting nature of existence and the depth of our experiences. In exploring these themes, art and literature not only reflect the passage of time, but also evoke a deeper understanding of its impact on human life, how it shapes our identities, relationships, and perceptions of the world around us. As we engage with these creative expressions, we are reminded that time is not just a linear measure, but a complex interplay intertwined with memory, emotion, and meaning. Through these lenses, we begin to appreciate the profound mystery that time holds, prompting us to think about our lives and the moments that define them. If society began to shift its understanding of time as an illusion, it could lead to profound changes in how we perceive our daily lives and interactions. Traditionally, time has structured our routines, dictating when we work, when we relax, and when we celebrate. However, if we viewed time differently, embracing the idea that it may not be a rigid framework, our approach to life could become more fluid. This new perspective might encourage a focus on the present moment rather than the relentless ticking of a clock. People could prioritize experiences over schedules, fostering deeper connections with others. Instead of rushing from one task to another, individuals might engage in more meaningful conversations, spend more time with family and friends, and fully immerse themselves in the activities they love. Shifting societal norms around time could also influence work practices. Companies might adopt more flexible schedules, valuing productivity over strict hours. This could lead to enhanced creativity and innovation, as employees feel less pressured by time constraints and more empowered to explore ideas at their own pace. Furthermore, this transformation in understanding could promote mindfulness and mental well-being. Emphasizing the importance of the present could lead to reduced anxiety about the future and regret about the past. People might cultivate habits that encourage reflection and personal growth, leading to a more compassionate society that values harmony over competition. Seeing time as an illusion could enable a cultural shift that prioritizes relationships and experiences rather than measurable achievements tied to strict timelines. The ripple effects of such changes would not only reshape individual lives, but also reconfigure the foundational aspects of communities and societies at large. Redefining time opens up fascinating implications for education. At its core, education is built around schedules, semesters, and learning timelines. If our understanding of time shifts significantly, it could change how we structure educational experiences. Imagine, for instance, if time were more flexible or if it expanded and contracted based on individual needs. In such cases, learning could become far more personalized. Students might advance at their own pace, taking the time they genuinely need to grasp challenging concepts without the pressure of a traditional clock. Furthermore, if time was seen differently, educational environments could adapt more dynamically. Classroom settings might transform, allowing for immersive experiences that blend various learning methods and timelines. For subjects like science, this could mean deep dives into topics without the constraints of set class periods. Students could engage with material in a manner that reflects their personal interests and curiosity, fostering a deeper understanding and love for learning. Additionally, a redefined sense of time could impact collaborative learning. If groups of students work together but experience time differently, they might develop unique approaches to projects. This could enrich the learning experience, encouraging creativity and innovation as they explore ideas through shared but divergent timelines. Ultimately, redefining time in education could create a system that emphasizes mastery over memorization, celebrating growth and exploration. It would encourage educators to focus not just on the material covered, but on the journey, making learning a more enriching and fulfilling experience for everyone involved. Looking at the universe from a cosmic perspective invites us to reconsider how we view both history and our plans for the future. Historically, we often think of events as isolated happenings, influenced primarily by human decisions. However, when we recognize our planet as a tiny speck in a vast cosmos, it becomes clear that our history is intertwined with the broader story of the universe. Events like climate changes, natural disasters, or even the movements of celestial bodies have shaped human experiences in significant ways. These occurrences remind us that human history is part of a larger narrative that includes influential forces far beyond our control. As for future planning, this perspective encourages us to think more holistically. Imagine planning with the awareness that our actions play a role not just in our immediate surroundings, but extend into the delicate fabric of the Earth's ecosystems and beyond. Understanding that we thrive in a finite space within a vast universe can inspire us to adopt more sustainable practices. We might begin to view our future as connected to the health of our planet and the preservation of its resources. This cosmic outlook also prompts us to consider collaboration, both on our planet and potentially with other intelligent life forms, in navigating challenges that affect not just humanity, but all forms of life. A cosmic perspective can transform our understanding of history and future planning from an isolated view to one that recognizes the intricate web of connections that bind us to the universe. By fostering this awareness, we can create a more thoughtful and responsible path forward. When we explore the potential impacts of space exploration on legal and governmental systems, we enter a fascinating intersection of science and society. As human activities extend beyond Earth, new legal frameworks are needed to address the challenges and responsibilities that arise in outer space. Firstly, the question of ownership comes to the forefront. Who has the right to claim resources from the Moon, Mars, or asteroids? Currently, international treaties state that space is a common heritage of mankind, which means no one nation can claim sovereignty over celestial bodies. This principle encourages cooperation, but also sparks debates on how to manage resources like minerals or water that may benefit humanity. Furthermore, space exploration raises significant questions about environmental regulations. Space junk, or debris left behind from satellites and spacecraft, poses a danger to current missions and the international space environment. Governments may need to establish guidelines for minimizing this risk and ensuring sustainable practices in order to protect the space environment for future generations. Additionally, the presence of private companies in space travel and exploration complicates legal governance. As more private enterprises launch their own missions, establishing clear regulations on liability, safety standards, and accountability becomes crucial. In the event of an accident, understanding who is responsible, whether it be the company, the country, or even the astronauts, must be defined clearly. Moreover, if humans begin to colonize other planets, entirely new legal systems may emerge. The challenges of governance in a distant colony could be unprecedented, leading to discussions on citizenship, rights, and laws that apply beyond Earth. This would likely require international cooperation to ensure that governance in space respects universal human rights. Lastly, the militarization of space is another pressing issue. As nations develop technologies for defense purposes that can operate in outer space, this raises concerns about potential conflicts and the need for treaties to maintain peace and cooperation in an arena that is meant for exploration and discovery. Overall, the implications of space exploration on legal and governmental systems are vast and complex. As humanity expands its horizons, establishing regulations and frameworks will be essential to ensure that space remains a domain of collaboration, advancement, and respect for our shared cosmic resources. Cultural narratives about destiny and fate often frame our understanding of time in fascinating ways. Many societies view time as a linear journey, moving from past to present to future. In this view, destiny suggests that the future is predetermined, guiding individuals along a specific path. This can create a comforting sense of purpose, as people believe their lives are part of a larger plan. However, the concept of the illusion of time introduces a different perspective. From a scientific standpoint, time is not as fixed as it seems. It can be perceived as a sequence of moments that unfold in a manner dictated by individual experiences and choices. When we consider that human emotions and actions shape our reality, the future becomes less about fate and more about potential. The intertwining of these ideas can lead to a conflict between feeling that one's life is directed by destiny and recognizing the freedom to make decisions that influence outcomes. This duality can create a rich narrative in storytelling across cultures, where characters may struggle against their perceived fate or embrace it, often reflecting the human condition and our search for meaning. While cultural beliefs anchor many to a notion of predetermined destinies, the fluidity of time and personal agency suggests that individuals can navigate their paths, creating a tapestry of experiences that overlap between fate and choice, reminding us that how we perceive time affects how we interpret our lives and destinies. Groundbreaking experiments have transformed our understanding of time, revealing it to be both a constant flow and a flexible dimension. One of the most pivotal experiments involves atomic clocks, sophisticated devices that measure time by counting the vibrations of atoms. These clocks have shown that time can actually pass at different rates depending on speed and gravity. For example, when clocks are flown in airplanes or placed at varying altitudes, scientists observe that time measured on the ground can differ from that in flight or at higher altitudes. This phenomenon, known as time dilation, reveals that time is not uniform but is influenced by motion and gravity. Additionally, experiments at particle accelerators have accelerated particles close to the speed of light, illuminating how time slows down for those particles relative to stationary observers. This starkly contrasts our daily experiences. We perceive time as a steady march forward, but at extremely high speeds, this linearity collapses, becoming a relative experience. Moreover, studies involving gravitational waves provide insights into the fabric of space-time itself. By observing these ripples in the universe produced by massive cosmic events like merging black holes, scientists gain a deeper understanding of how time and space interact in a dynamic universe. These discoveries challenge traditional notions of a fixed timeline, suggesting that time behaves more like a tapestry woven intricately with the universe's curvature and energy. Finally, experiments exploring the concept of quantum entanglement propose that time may not be the same for all particles. When entangled particles communicate instantaneously across vast distances, it raises questions about the very nature of causality, when cause leads to effect, and whether time is as linear as we often assume. Together, these findings reveal time as a complex, multifaceted dimension that is deeply intertwined with the fabric of reality, continuously reshaping our understanding of the universe. Technological developments have significantly deepened our understanding of time and its fluidity. In the past, time was often seen as a constant and unwavering measure, much like a steady clock ticking away. However, innovations in technology have allowed scientists to explore and observe how time can change based on different factors. One of the most influential advancements comes from highly precise atomic clocks. These devices measure time based on the vibrations of atoms, which are incredibly consistent. By using these clocks, researchers can detect variations in time that occur due to differences in gravity and speed. This is where Einstein's theory of relativity enters the picture. The theory suggests that time moves slower in stronger gravitational fields. For instance, time is slightly slower on the surface of Earth compared to a spacecraft far away from its gravitational pull. With atomic clocks placed both on the ground and in orbit, scientists have directly measured this difference, proving that time is not as rigid as it once seemed. Additionally, technological advancements in satellites and GPS have provided practical applications of this understanding. GPS systems rely on precise time measurements to pinpoint locations. If they did not account for the slight differences in time due to gravity and speed experienced by satellites, the location readings would quickly become inaccurate. This integration of technology not only enhances navigation, but also solidifies the concept that time is affected by physical conditions. Moreover, experiments involving particle accelerators have shown how time behaves differently at high speeds. Particles moving close to the speed of light experience time more slowly than those at rest. These observations reinforce the idea that time can stretch or compress, depending on circumstances. Modern technology has transformed our perception of time from a fixed tick-tock rhythm into a more fluid, adaptable concept influenced by speed and gravity. As we continue to innovate and explore, our appreciation for the complexities of time only deepens, revealing the universe's many layers and how interconnected space and time truly are. Particle accelerators are powerful tools that help scientists unlock the secrets of the universe, including the nature of time. Imagine a racetrack where tiny particles, much smaller than atoms, are sped up to nearly the speed of light. In accelerators, these particles collide with immense energy, creating conditions similar to those just after the Big Bang. This allows scientists to observe fundamental forces and particles that shaped our universe. One fascinating aspect revealed by these collisions is the behavior of particles under extreme conditions. When particles move so fast, their mass effectively increases, and time appears to slow down for them when viewed from a stationary point of reference. This effect, known as time dilation, confirms predictions made by Einstein's theories about time and space, showcasing that time is not a constant, but is heavily influenced by speed and gravity. Moreover, by studying the particles created in these high-energy collisions, researchers can trace how these particles decay over time. Understanding these decay processes helps scientists piece together the timeline of the universe's evolution from the moment of its birth to the present day. Each discovery made in these investigations contributes to a greater understanding of how time works, its relationship with space, and how the fundamental fabric of reality operates at its most basic level. Through particle accelerators, we are not only peering into the building blocks of matter, but also grappling with the very nature of existence itself, helping to unravel the mysteries of time. Astronomical observations have profoundly influenced how we understand time, showing that it is not as straightforward or linear as we once believed. For centuries, people thought of time as a simple, unchanging line, where past events led directly to the present and then the future. However, when we began to observe the universe, we encountered phenomena that complicate this view. For instance, when we look at distant stars and galaxies through powerful telescopes, we are not seeing them as they are right now. Instead, we observe light that has traveled for millions or even billions of years to reach us. This means we are essentially looking back in time, witnessing the universe as it existed long ago. This realization highlights that our present moment is intertwined with a past that we can still observe because of the finite speed of light. Moreover, certain celestial objects like supernovae or cosmic events reveal that the fate of the universe itself is tied to a more intricate timeline than we previously understood. The expansion of the universe, for instance, challenges the notion of a fixed time frame. As the universe continues to stretch, galaxies move away from one another, suggesting a dynamic and ever-changing timeline rather than a singular path. Additionally, theories of relativity introduced by scientists like Einstein show that time can be affected by gravity and motion. In strong gravitational fields or at high speeds, the passage of time can change. For someone near a massive object like a black hole, time flows differently compared to someone further away. This idea that time can stretch or compress adds further complexity to our understanding of time as not just linear but also elastic. Together, these observations and theories suggest that time is more like a fabric, rich in layers, influences, and connections, rather than just a simple line. Our conception of time has expanded from being a straightforward progression to a landscape filled with depth, where past, present, and future are interconnected in ways we are still learning to understand. Artificial intelligence has opened new doors in our understanding of time, revealing surprising insights that challenge conventional thinking. One interesting development involves the way AI analyzes vast amounts of astronomical data. Traditionally, scientists would study the motion of celestial bodies over the years and apply complicated mathematical models to predict their movements. AI, however, can quickly process this extensive information, identifying patterns far more efficiently. This has led to new conclusions about how time plays a role in the formation and movement of galaxies. Moreover, researchers have utilized AI to explore the nature of time at the quantum level. At this tiny scale, particles behave unpredictably, and their interactions can seem to defy the normal flow of time we experience. AI models can simulate these behaviors, offering insights into how time might be woven into the fabric of the universe itself. This has prompted fresh discussions about the existence of time and whether it is a fundamental aspect of reality or a human perception influenced by the universe's mechanics. Another surprising discovery centers around the effects of time dilation, where time is perceived differently based on speed and gravity. AI systems have analyzed data from various experiments and observations, revealing more nuanced effects of time dilation than previously understood. By synthesizing data from satellite imagery and ground-based observations, AI has been able to illustrate the complex interplay between high-speed travel and the passage of time. Lastly, the predictive capabilities of AI also bring fascinating implications for timekeeping and even the concept of time itself. By examining historical patterns and social dynamics, AI can anticipate future trends with remarkable accuracy. This evolution in understanding time, not just as a metric, but as a fluid concept influenced by various factors, underscores the profound impact of artificial intelligence in the quest to decode one of the universe's most enigmatic elements. As AI continues to evolve, so too will our insights into the mysterious nature of time itself. Meteorological cycles and celestial events are fascinating examples of how time is structured and perceived in our world. Consider the changing of the seasons. This is a cycle deeply tied to the position of Earth in relation to the Sun. Each season lasts for about 3 months and brings different weather patterns and temperatures. This predictable cycle helps us to plan our lives, but it also reminds us that time moves rhythmically, shaped by astronomical mechanics. Now, turning to celestial events such as eclipses, comets, or planetary alignments, we see another layer of complexity. For instance, a solar eclipse occurs when the moon passes directly between the Earth and the Sun. This event is infrequent and appears at specific intervals, which can be calculated through historical records. The anticipation of such rare occurrences highlights how ancient civilizations tracked time based on the sky, establishing calendars and celebrations centered around these events. The synchronization between weather patterns and celestial movements demonstrates that time is not just a static measure, but is deeply intertwined with natural rhythms. This intertwining can make time feel elastic. While we experience days, months, and years as consistent units, our perception of time can vary greatly depending on the cycles around us. In moments of extraordinary celestial events, time seems to pause as we become fully engrossed in the spectacle above us. Understanding these cycles and events gives us insight into the intricate layers of time, revealing that it is both personal and universal. While our daily lives tick by at a steady pace, the larger natural world operates in its own tempo, reminding us of the interplay between our existence and the vast cosmos. This relationship illustrates how our perception of time can shift, influenced by both earthly and celestial phenomena, highlighting the complexity of what time truly means. The universe is filled with mysteries that challenge our understanding of physics and nature. Some of these phenomena leave scientists scratching their heads and pondering the very laws that govern our existence. One such enigma is dark matter. This invisible substance does not emit light or energy, making it undetectable by traditional means. Yet its presence is inferred from the way galaxies rotate and the gravitational effects they exert on surrounding matter. This perplexing aspect of the universe hints at a reality beyond what we can see. Another captivating phenomenon is dark energy. This force is believed to be responsible for the surprising acceleration of the universe's expansion. Though we can measure this expansion, the underlying cause remains elusive. dark energy challenges our perception of gravity and the fate of the universe itself, suggesting there are forces at play that we have yet to fully comprehend. Quantum entanglement presents yet another conundrum. In this strange realm of quantum mechanics, particles become intertwined in such a way that the state of one instantaneously affects the state of another, regardless of distance. This interaction seems to defy the classical ideas of space and time, raising questions about the very fabric of reality itself. Lastly, we encounter the phenomena of fast radio bursts, which are brief flashes of radio waves from deep space. The origins of these bursts remain uncertain, with theories ranging from neutron stars to alien civilizations. Their sudden occurrence and the immense energy they release present a tantalizing puzzle that continues to intrigue astronomers. These mysteries are more than mere curiosities. They challenge our scientific principles and expand our understanding of the cosmos. As our technology and knowledge evolve, each discovery leads to more questions, keeping the pursuit of knowledge ever more exciting. Time has always held a powerful allure, presenting a kaleidoscope of mysteries that ignite human curiosity. From the fleeting moment of a sunset to the vast stretches of cosmic history, time seems to shape every facet of our existence. As people ponder the nature of time, they might wonder how it flows, whether it is linear or cyclical, and what lies beyond the limits of our perception. This intrigue encourages exploration and fuels a desire to understand not only our place in the universe, but also the very mechanics of life itself. Human beings are naturally drawn to the unknown, and time, with its elusive qualities, often feels like one of the final frontiers. Think of scientists who study ancient fossils, unraveling stories millions of years old, or astronomers who gaze at distant stars, catching glimpses of light that took ages to reach our eyes. Each discovery about time can unveil a thread of connection between the past and the present, fostering a deeper understanding of our own journey. This quest for knowledge is not just limited to the scientific realm. Literature, art, and philosophy all wrestle with the concept of time, reflecting the profound impact it has on our emotions and choices. Whether contemplating the fleeting nature of a day or the eternal dance of celestial bodies, we find ourselves captivated by its mysteries, inspiring countless questions that challenge our understanding. In this way, the kaleidoscope of time doesn't just inspire curiosity. It connects us to the fabric of existence and allows us to imagine what lies in the future, making us ever more inquisitive about the cosmos and our role within it. Time has always fascinated humanity, stirring deep questions that prompt ongoing scientific exploration. One fundamental question is, what is the true nature of time? Is it a physical entity that flows, or is it more an abstract construct of our perception? This inquiry drives scientists to explore whether time exists independently or if it is merely a measure of change or events occurring in the universe. Another intriguing question revolves around the beginning of time. If we think about the Big Bang as the origin of our universe, does that mean time itself had a starting point? This concept raises questions about what existed before that moment and challenges our understanding of causality. If time began at the Big Bang, then asking what happened before that event leads to a frontier of unknowns that scientists are eager to explore. The nature of time in relation to space is also a crucial aspect. How does gravity influence the passage of time? According to Einstein's theory of relativity, the stronger the gravitational field, the slower time moves relative to a weaker field. This has endless implications, such as the effects for astronauts on journeys through space and near massive objects like black holes, where time behaves in remarkable and often strange ways. Additionally, the idea of time travel invites thrilling speculation. Can we ever move backward or forward through time? Various theories suggest possible methods, but no practical approach exists yet. The exploration of these theories brings up profound implications about free will, destiny, and the fabric of reality itself. Moreover, the question of how time affects human existence and consciousness continues to intrigue scientists and philosophers alike. How do our brains perceive and measure the passage of time? And why does it sometimes feel like time flies while at other moments it crawls? Understanding our perception of time can reveal much about human cognition and emotions. With these questions, scientists are not only seeking answers but also uncovering new dimensions of knowledge, constantly reshaping our understanding of this mysterious and captivating phenomenon known as time. Time has a fascinating and complicated nature that is showcased in the concepts of spontaneity and unpredictability. When we think about spontaneity, we often consider moments that happen without warning, events that catch us by surprise and lead to unforeseen outcomes. In our daily lives, these moments can change our paths dramatically, highlighting how fluid and dynamic our experiences of time can be. Similarly, unpredictability further emphasizes this quality of time. The universe operates under a set of laws, yet despite the patterns we observe, there is always an element of chance. For example, in the realm of quantum physics, particles behave in ways that cannot be predicted with absolute certainty. They exist in states of possibility rather than fixed outcomes. This means that even at the very small scales, time is intertwined with unexpected events, reminding us that not everything can be neatly calculated or anticipated. Together, spontaneity and unpredictability create a sense of mystery surrounding time. They make us aware that while we can track time and observe its effects, we cannot always control or foresee how it unfolds. This blend of certainty and uncertainty challenges our understanding, making time not just a measure of change, but also an unpredictable voyage filled with surprise. Time is both a guide and a puzzle, offering continuous opportunities for discovery that keep us engaged with our reality. Cognitive sciences offer a fascinating lens through which we can explore the nature of time. At its core, time is not only a measurement of days, hours, and seconds, it is also intrinsically linked to our perception and experience. Cognitive scientists study how we understand and interact with time, revealing that our brains process time in unique and sometimes surprising ways. Consider how we perceive time passing. Our sense of time often stretches or compresses based on our experiences. For instance, a thrilling roller coaster ride can feel fleeting, while a boring lecture might seem to drag on endlessly. This subjective experience of time shows that our emotions and concentration can greatly influence how we perceive its flow. Cognitive sciences delve into the mechanisms behind this, how attention, memory, and emotions work together to shape our personal timelines. Researchers in cognitive sciences have also examined how the brain encodes time. Some areas are dedicated to processing duration, while others help us understand the sequence of events. This helps us not only place events in chronological order, but also anticipate what may happen next. The concept of mental time travel emerges here, where our minds can leap backward to recall past moments or forward to imagine future scenarios. This ability is crucial for planning and decision-making. Furthermore, cognitive studies have shown that our understanding of time can be culturally influenced. Different cultures may emphasize punctuality or fluidity regarding time, which can shape how individuals within those cultures perceive and interact with time. The blend of psychology, neuroscience, and philosophy in cognitive sciences ultimately leads to richer insights into how we experience time, helping us grasp its complexities on both a personal and societal level. By examining the cognitive processes involved in how we perceive and comprehend time, we uncover much about not just time itself, but also about our consciousness and the human experience. Neuroscientific research has uncovered fascinating insights into how our brains perceive time. Time is not something we experience as a simple flowing stream. Rather, it is processed in complex ways that can vary based on numerous factors. One of the key findings is that our sense of time can stretch or compress depending on the events around us. For instance, when we experience something new or exciting, such as a thrilling adventure, time often feels like it is moving more slowly. This effect happens because our brains are working harder to process all the new information. It creates rich memories that give us a sense of a longer duration. Conversely, during routine or monotonous tasks, time can seem to speed up. The brain is less engaged in processing familiar stimuli, leading to fewer memorable events. This is why, as we often say, time flies when you're having fun and stretches when we are bored. Another intriguing aspect of time perception involves attention and emotion. When we are focused on a task or feeling strong emotions, our perception of time can alter significantly. For example, during heightened emotional states like fear or excitement, time may be perceived as ticking by slower because the brain is prioritizing and recording those details vividly. Research also indicates that different brain regions play specific roles in how we perceive time. The brain's internal clock, which helps us estimate the passage of time, involves several interconnected areas that track and gauge duration. Disruptions or variations in this neural circuitry can lead to distorted time perception, which can be observed in certain neurological conditions. Overall, our experience of time is subjective and influenced by our mental state, the nature of our experiences, and even the external environment. Understanding how we perceive time can give us deeper insights into consciousness and the human experience itself. Altering consciousness, such as during sleep or while dreaming, can have a significant impact on how we perceive time. When we enter different states of awareness, our brain processes information in unique ways, which can distort our sense of the passage of time. During regular waking hours, our perception of time is largely influenced by external cues, such as clocks or the rhythm of daily activities. However, in a dream state, those cues can disappear. Without the usual markers to gauge time, dreams can feel like they last for a long while, even when only a few minutes have passed in reality. This is why people often awaken from a dream and feel as if they have experienced an entire journey or adventure, although it may have occurred in a fraction of what they thought was time spent asleep. The brain's activity during dreams is quite intense, resembling wakefulness in many aspects. This heightened activity can lead to vivid experiences where the usual boundaries of time blur. We may encounter events that seem to stretch on or compress in ways that do not align with our everyday understanding of time. Furthermore, when we enter altered states through meditation or certain psychological experiences, similar effects can occur. Engaging deeply with thoughts or sensations can create a sense of timelessness, where past and future feel intertwined and the present moment expands or contracts. Such experiences highlight the fascinating interplay between consciousness and our perception of time, revealing just how fluid and subjective our understanding of time can be. Psychedelic experiences often lead people to perceive time in a way that feels fluid and distorted, challenging our everyday understanding of it. Normally, we experience time as a steady progression, a pathway where moments flow from past to future in a linear fashion. However, under the influence of psychedelics, many report feeling as if time stretches, compresses, or even loops back on itself. Imagine standing in a room where a clock ticks away the seconds, yet when psychedelic substances alter perception, that same clock may lose its meaning. Moments can feel incredibly elongated. A few minutes might seem like a lifetime. Alternatively, the past may feel indistinct, blending into feelings and sensations without clear separation. This fluidity reveals how our brains construct the experience of time based on context, emotions, and sensory input, rather than relying on a strict, measurable framework. This perspective can lead to insights about the nature of reality itself. When individuals come to understand that the rigid boundaries they usually associate with time are, in fact, influenced by subjective experience, it opens up new ways of thinking. Rather than viewing time as a linear, unchanging path, they may begin to see it as more of a tapestry woven from memories, emotions, and the present moment, suggesting that our perception shapes our reality. Ultimately, these profound realizations during psychedelic experiences can promote feelings of connectedness and timelessness. They can illuminate the idea that human existence is less about ticking seconds and more about shared experiences and moments that transcend the boundaries of time. This understanding can lead to greater mindfulness and appreciation of the present, reminding us that life is not merely about the passage of time, but about how we engage with each fleeting moment. As we age, our perception of time often changes in surprising ways. When we are young, every experience feels new and vivid. A week can feel like an eternity because each moment is packed with discovery and learning. Think of childhood, where a single day might seem filled with countless adventures. It's a time rich with firsts: first day of school, first bicycle ride, first time eating ice cream. As we transition into adulthood and beyond, our lives tend to settle into routines. Days may blend together and experiences start to repeat. This familiarity can make time feel like it's accelerating. A year may pass quickly, not because time itself is moving faster, but because we are encountering fewer novel experiences that stimulate our sense of time. Our brain processes rapid experiences differently than routine ones. Therefore, the more we repeat actions and experiences, the less our brain registers them, leading us to feel like time is flying by. Moreover, The way memories are formed changes with age. Younger people tend to create more detailed and distinct memories, while older adults may remember significant events less vividly. This can further contribute to the sensation that time is moving quickly, as fewer memories translate to fewer markers of time passed. To illustrate, think about a summer vacation spent exploring new places. The memories generated can stretch that season into what feels like a long and enriching experience. In contrast, a summer spent in the same surroundings might fly by without leaving many memorable impressions. Lastly, emotional factors play a crucial role in our perception of time. Stressful period or moments filled with excitement can feel slow in the moment, while a peaceful routine may blur together. This emotional coloring adds yet another layer to how we experience the passage of time throughout our lives. As we grow older, recognizing and creating new experiences can help slow down this perceived rush, allowing us to savor the moments that we might otherwise let slip away. Throughout the history of science, several classic thought experiments have stirred our understanding of time and challenged conventional perspectives. One prominent example is Einstein's train thought experiment. Imagine a train traveling at a high speed, with an observer on the platform watching as two lightning strikes hit either end of the train simultaneously. However, for someone inside the train, the moment those strikes occur is experienced unevenly due to the motion of the train. This brings forth the idea that time can be perceived differently depending on one's frame of reference, suggesting that time is not a constant but is influenced by speed. Another influential concept comes from the philosopher thought experiment known as the twin paradox. In this scenario, one twin travels into space at nearly the speed of light, while the other stays on Earth. When the traveling twin returns, they find they have aged less than their sibling. This illustrates how time can elapse at different rates based on relative velocity, fundamentally questioning the uniformity of time across different observers. Then there is the notion of time travel itself, often explored in various scenarios like the idea of going back in time to change an event. This leads to paradoxes, such as the famous grandfather paradox, where a time traveler could inadvertently prevent their own existence. These complex ideas reveal time not merely as a straight line, but as a more intricate fabric woven with potentialities and constraining realities. These thought experiments do more than entertain. They push us to reconsider our basic assumptions about time, suggesting it is a dynamic entity interwoven with space and perception rather than a separate, unchangeable backdrop against which events unfold. Ultimately, they encourage a deeper inquiry into the nature of time itself, revealing complexities that challenge traditional views and invite further exploration in both physics and philosophy. Hypothetical scenarios play a significant role in helping us grasp the complex nature of time and its flexibility. By imagining situations where time behaves in unusual ways, we can better understand concepts that are often hard to visualize. For instance, consider a thought experiment where people can travel into the past. This scenario allows us to contemplate the paradoxes that arise, like meeting our younger selves or changing events that shape our present reality. Through these examples, we can recognize that time is not just a straightforward linear path. It can be perceived as a more flexible landscape, where our actions might ripple through various timelines. Another engaging example is to envision a world where time moves differently for different observers. Imagine two people watching the same event, but one is near a massive object like a planet, while the other is far away. Through this scenario, we see how gravity can affect the passage of time, making it seem to flow slower for the one close to the planet. Such hypothetical situations illuminate the idea that time is affected by various forces in the universe, including gravity and velocity. In these ways, hypothetical scenarios serve as a powerful tool. They allow us to explore the intricacies of time, nudging us to think beyond the confines of our everyday experiences. By stepping into new realities, we can appreciate the remarkable and sometimes mind-bending nature of how time may function, adapting to the incredible dynamics of the universe. To truly appreciate or challenge the illusion of time, we need to explore several key questions. First, what is time, and how do we define it? At its core, time is often seen as a measure of change or a way to sequence events. We experience time as a continuous flow, but its nature remains deeply mysterious. Next, we must ask, how do we perceive time? Our senses create the impression of time passing, but our experience can vary significantly based on context, emotions, and activities. When we are engaged in something enjoyable, time seems to fly, whereas during unpleasant moments it drags on. This subjectivity invites us to consider whether time is an objective reality or simply a psychological construct. Another vital question is whether time is the same for everyone. Scientific theories suggest that time can stretch and compress depending on speed and gravity. This means that a person could theoretically experience time differently than someone else based on their location and motion. Investigating this can lead to a deeper understanding of how intertwined time is with the fabric of the universe. We should also question, how does time connect with other dimensions? In physics, particularly in the context of relativity, time is not just a standalone feature, it's intertwined with space. Together, they form what we call space-time. Exploring this relationship raises questions about the very foundation of reality and the possibility of time behaving differently under extreme conditions. Lastly, we need to consider the implications of time flowing in one direction, what is known as the arrow of time. This unidirectionality appears connected to the increase of disorder or entropy in the universe. Understanding why time seems to move forward and not backward can help clarify the broader concepts of existence and change. By addressing these fundamental questions, we can begin to untangle the complex nature of time and its role in our universe, ultimately allowing us to appreciate its significance or perhaps debunk the ways we perceive it. Considering time from a philosophical perspective opens up new avenues for scientific exploration by encouraging deeper questions about existence and our place in the universe. Philosophy challenges us to think critically about concepts like past, present, and future, urging scientists to not only measure time, but to understand what it means. For instance, when we examine the nature of time, we find ourselves questioning whether it is a linear progression or if it exists in cycles, or perhaps even simultaneously in various forms. Philosophical inquiries can drive inquiry into how time impacts the fabric of reality itself. They prompt scientists to think about temporal phenomena, such as how time may be perceived differently depending on relative motion or gravity, as illustrated in the theory of relativity. Moreover, these discussions may lead to advancements in technology, such as more precise methods for studying the universe or exploring concepts of time travel. Ultimately, by merging philosophical contemplation with scientific investigation, we not only advance our technical knowledge, but also enrich our understanding of the universe and our role within it. This fusion invites a more holistic view, where the mysteries of time propel us into realms of exploration, creativity, and innovative thought. Personal beliefs and spiritual perspectives give us unique lenses through which we perceive time's reality. To many people, time is not simply a measurement of seconds, minutes, and hours. It can embody experiences, memories, and growth. Some cultures view time as cyclical, where events repeat themselves in a continuous loop, while others see it as linear, moving from past through present to future. In spiritual contexts, time might be regarded as an illusion, suggesting that our focus on past regrets or future anxieties can distract us from the present moment. Some philosophies propose that the present is all that truly exists, highlighting the importance of mindfulness. This leads to a profound connection with the now, urging individuals to fully engage with their current experiences. Moreover, certain spiritual beliefs may suggest that consciousness influences the perception of time. In these views, time can stretch or contract based on emotional states or spiritual insight. Moments of intense joy, fear, or deep reflection can seem to stretch out, while periods of routine or monotony may fly by. The intersection of personal beliefs and spirituality with time creates a rich tapestry of understanding. It encourages exploration beyond the scientific definitions, inviting each individual to ponder their own relationship with time and its meaning in their life. This blend of subjective experience and cultural narratives enriches our conversation about time, revealing a universe where science and spirit can coexist in intriguing ways. Imagery plays a crucial role in helping us grasp the elusive nature of time. When we envision time as a river flowing steadily, we can imagine how its currents can quicken or slow, reflecting the moments that feel fleeting versus those laden with intensity. This river metaphor illustrates that while we might experience time's passage differently, it is constantly moving forward. Now, think about time as layers of an onion. Each layer represents a different moment or memory. Peeling back those layers allows us to see how past experiences shape our perception of the present. In this view, time is not just a linear path, but a rich tapestry woven with events that intertwine and influence each other. By representing time as a stretched rubber band, we can envision how it can be compressed or extended. In those moments of joy or excitement, time often seems to fly by, while in times of sorrow, every second can drag on painfully. This flexible nature of time suggests it is more of a subjective experience than a rigid measurement. Imagery can create relatable experiences that make abstract concepts like time much more tangible. By invoking these visual representations, we can better understand how time not only progresses, but also how it impacts our lives in profound ways, shaping our memories and emotions. Visual metaphors are powerful tools for conveying complex concepts about time in ways that resonate with our everyday experiences. When discussing time, it can be abstract and difficult to grasp, as we cannot see it or touch it directly. By using visual metaphors, we can turn these intangible ideas into something relatable and understandable. For example, when time is likened to a river flowing steadily, it helps us visualize how time moves constantly onward. This analogy suggests that just as a river's flow can speed up in certain areas or slow down in others, time too can seem to move differently depending on the circumstances. This makes the concept of time feel accessible and familiar. Another common visual metaphor is comparing time to a fabric or a timeline that weaves together different events. This concept allows us to think about how past, present, and future are interconnected, much like threads stitched into a tapestry. This framework can help us understand how actions today might ripple into future circumstances. By employing these kinds of visual representations, educators and communicators can distill complex ideas about time into simpler elements that break down barriers of comprehension. Such metaphors create mental images that stay with us, illustrating how time can stretch, bend, or be perceived in various ways, enhancing our understanding of its deeper implications. Ultimately, visual metaphors serve as bridges, connecting abstract scientific ideas with the human experience and making the mysteries of time a little less daunting. Animation and digital effects have the remarkable ability to transform our understanding of time in ways that are visually engaging and thought-provoking. When creators want to illustrate how time can be experienced differently, perhaps much like how astronauts perceive it in space, they use visual techniques that manipulate speed, motion, and perspective. For instance, imagine a scene where a character is moving through an environment while everything around them is either speeding up or slowing down. This juxtaposition conveys a sense of time distortion. It visually suggests that the character is interacting with time differently than the world surrounding them. By slowing down fast movements, like a blink of an eye or a drop of rain, the audience can witness details that would otherwise go unnoticed, creating a feeling that time is stretching or transforming. Additionally, using techniques such as time-lapse can compress long durations into mere moments of visual storytelling. Viewers see a flower bloom or a sunset transition quickly, reinforcing the idea that while we experience time linearly, it can also be viewed in snapshots or flashes that emphasize change. This contrast highlights the relativity of time. In a different space or given a different perspective, the pace of life can feel dramatically altered. Digital effects can also mimic the visual manifestations of time dilation, an idea rooted in the laws of physics where time passes at different rates in varying gravitational fields or speeds. For example, in a scene where a spaceship approaches a black hole, the visuals might stretch or distort, depicting the slowing of time as the forces of gravity play a role. As the audience witnesses these effects, they gain a deeper sense of how time might not be as absolute as it seems, but can indeed be bent and shaped by factors beyond our immediate perception. By utilizing these animation and digital effects techniques, filmmakers can challenge the conventional flow of time, making the abstract concept more tangible and engaging for viewers, and ultimately allowing us to consider how our reality may be just one of many ways time can be experienced. Filmmakers, artists, and creators explore the idea that time might be an illusion in several innovative ways, captivating audiences and provoking thought. One common method is through visual storytelling. They often manipulate the perception of time by using slow motion or fast-paced sequences. For example, in a slow-motion scene, actions unfold gradually, allowing viewers to immerse themselves in every detail, creating a sense that time is extending. Conversely, when sequences are sped up, it can evoke the feeling that time is racing by, transforming ordinary moments into fleeting experiences. Another technique involves non-linear narratives, where the story isn't told in a traditional chronological order. This approach allows creators to hop between different moments in time, highlighting the connections between past, present, and future. By shifting timelines, they can illustrate the idea that our perception of time is subjective and can be experienced differently by each character. This kind of storytelling encourages the audience to think about how memories shape their understanding of time. Visual artists similarly play with this concept through their work. They might create a series of paintings or sculptures that depict the same scene at different times of day, capturing the changing light and atmosphere that suggest an ongoing experience rather than a fixed moment. This invites viewers to question whether time is a constant reality or simply a construct based on perception. Music and sound design also play a vital role in conveying the fluidity of time. Composers use rhythm and tempo changes to evoke various emotional responses, making moments feel prolonged or hurried. Soundscapes may incorporate echoes or layered sounds, creating a sense of the past lingering in the present, further reinforcing the idea that our experience of time is multifaceted and perhaps deceptive. Through these techniques, filmmakers and artists encourage audiences to reflect on their own experiences with time, prompting a deeper consideration of what time truly means to us. The exploration sparks dialogue about memory, existence, and the nature of reality, making the concept of time not only a subject of fascination, but also a powerful vehicle for storytelling. Visual storytelling can beautifully capture the mysteries of time by employing a variety of techniques that engage the audience's imagination and curiosity. One powerful method is using time-lapse photography. This technique shows how landscapes evolve and change over extended periods, like watching flowers bloom in a matter of seconds or cities pulse with life throughout the day. It compresses time, transforming hours, days, or years into captivating segments that highlight the passage of time. Another effective approach is contrasting stillness with movement. For instance, depicting a ticking clock alongside fast-moving clouds can create a sense of tension between the relentless march of time and our experiences. This juxtaposition encourages viewers to contemplate how time feels different depending on context, sometimes moving quickly, other times dragging on. Incorporating visual metaphors is also impactful. A river flowing steadily can symbolize the continuous flow of time, while seasons changing can represent life's cycles. These symbols make abstract concepts more relatable and easier to understand, drawing the viewer in. Furthermore, using gradual transformations in colors and lighting can signify the transition of time. A scene moving from dawn to dusk, with warm golden hues morphing into cool bluish tones, evokes a natural sense of time passing. This technique not only highlights the beauty of change, but also evokes emotions related to nostalgia or anticipation. Finally, integrating narrative techniques involving character experiences can humanize the concept of time. By following a character through meaningful moments, witnessing their growth or loss, viewers can connect deeply with the idea of time as a transformative force in life. Collectively, these visual methods not only illustrate time's complexities, but also invite the audience to ponder their own relationships with the passage of time, making the experience both personal and profound. Cosmological theories often present time in ways that challenge our everyday understanding. Traditionally, we see time as a straightforward progression, like a river flowing steadily from the past to the present and into the future. However, some scientific perspectives suggest that time may not be as concrete as it appears. One influential idea posits that all moments, past, present, and future, exist simultaneously in a kind of timeless block. This theory is called block universe theory. In this view, what we perceive as the passage of time is more like a changing perspective. Just like looking at a painting, every part of the painting exists at once, but our focus shifts around it. Another approach comes from the realms of quantum mechanics and relativity, where time may not have a uniform flow. According to Einstein's theory of relativity, the passage of time can vary depending on speed and gravity. This suggests that time might stretch and compress, leading us to question its reliability as a constant measure. When we consider these ideas together, it becomes clear that time might be an emergent property, a byproduct of other processes rather than a fundamental element of the universe. In this understanding, the steady tick of time is like an illusion, shaped by our perceptions and the intricate interplay of cosmic laws. Ultimately, these theories invite us to reconsider our relationship with time, suggesting that what we experience is merely a slice of a far more complex reality. Rather than a flowing river, time could be perceived as an intricate tapestry, where every thread is woven together, existing all at once in the vastness of the cosmos. Cosmic phenomena, like the movement of stars and the expansion of the universe, offer a unique lens through which we can understand time. Imagine standing still while observing the dance of the cosmos. Each twinkling star is not just a distant light. It represents a moment in history, as the light we see today may have traveled through space for millions or even billions of years. This journey of light helps us measure not just distance, but the passage of time itself. Additionally, the observable universe is in constant motion. Galaxies are moving away from us, suggesting the universe is expanding. This expansion means that as we look further back into space, we're also looking back in time. Scientists have noted that this relationship between distance and the age of light traveling to us provides key insights into the universe's history and age. Gravitational forces from massive objects, like black holes or neutron stars, also influence how time is experienced. Near a massive object, time runs differently. This peculiar effect, known as time dilation, tells us that time is not a constant but a variable shaped by gravity. Phenomena like these reveal deeper truths about time, showing it as a complex tapestry woven into the fabric of space itself. By studying cosmic events, from the explosive birth of stars to the gentle drift of galaxies, we gain clues about time's nature, discovering it as a dynamic element of our universe, shaped by its vast and sometimes violent history. The universe's grand tales teach us that understanding time is as much about observing the cosmos as it is about human experience on Earth. When we think of time in our everyday lives, we often tie it to minutes, hours, and years, all based on human experiences and activities on Earth. However, in the vastness of the universe, these familiar markers of time take on a different meaning altogether. The cosmic scale expands our view, revealing how time can appear stretched or compressed based on where you are and how you are moving through space. In the realm of space, the immense distances can create conditions where time behaves peculiarly. For instance, according to the theory of relativity, if someone were to travel at speeds close to that of light, time for them would slow down compared to a person remaining stationary on Earth. This means that while only a short duration passes for the traveler, many more years could unfold for those left behind. Additionally, the gravitational pull of massive objects like planets or stars can influence the passage of time. The stronger the gravity, the slower time moves. This means that a clock on a large planet might tick at a different rate than one in a weaker gravitational field, such as on a small moon in the outer reaches of the solar system. When astronomers observe light from distant galaxies, they don't just see light traveling for millions or even billions of years. They also witness how time itself has stretched across the universe. The light we see today from these far-off places carries stories of the past, as it has taken an incredibly long time to reach us. Therefore, each minute or hour that passes on Earth may not correspond to the same reality experienced elsewhere in the universe. These factors lead to the realization that time is not a simple, fixed unit, but rather a complex fabric influenced by speed and gravity. This cosmic perspective challenges our conventional understanding and illustrates that in the grand scheme of the universe, time is fluid and multifaceted, inviting us to rethink how we perceive our daily lives compared to the vast timelines of galaxies and stars. Celestial events offer a fascinating window into the nature of time, revealing its fluidity in remarkable ways. One of the most striking examples is a supernova, which is the explosion of a star at the end of its life cycle. When a massive star runs out of fuel, it collapses under its own gravity. This collapse happens rapidly, but what observers on Earth see is a brilliant light show that has traveled vast distances and taken years, sometimes even centuries, to reach us. During this cosmic event, we are witnessing the final moments of a star long gone, effectively illustrating how time can stretch and vary depending on our distance from the phenomenon. Another significant event is the movement of pulsars, which are highly magnetized, rotating neutron stars that emit beams of radiation. As these stars rotate, they send out pulses of energy like a lighthouse, creating a regular timing signal. If we could watch the pulse of a pulsar, we would notice that time appears to tick at different rates based on our location. This is directly influenced by the effect of gravity, which can differ across spatial dimensions. Such variations highlight not just the passage of time, but how it can bend and twist around massive objects. Finally, gravitational waves, ripples in space-time caused by events like colliding black holes or neutron stars, profoundly illustrate the dynamic nature of time. When these waves travel through space, they carry information about the events that created them, allowing us to observe moments that were otherwise invisible. The very detection of these waves showcases that time is not a singular path, but an interconnected web that can be altered and influenced by extreme cosmic events. Together, these celestial occurrences entice us to rethink our understanding of time, revealing it as a flexible entity shaped by the universe's grand mechanisms. Through their varied impacts, these events remind us that time is not just an unchanging backdrop, it is part of a much larger, living tapestry in the cosmos. The expansion of the universe plays a significant role in how we understand time itself. To grasp this connection, start by imagining the universe as a balloon that is being inflated. As the balloon expands, the dots on its surface, representing galaxies, move away from each other. This movement is not just about distance, but also about the fabric of time. As the universe expands, it alters the way we perceive time across different regions of space. For instance, light from distant galaxies takes a long time to reach us. When we look at a galaxy billions of light years away, we are not just seeing it as it is today, but rather viewing it from the past. The further a galaxy is, the longer its light takes to travel to us, meaning we are observing earlier stages in its evolution. Moreover, the rate of expansion can influence the flow of time within gravitational fields. According to the theory of relativity, the presence of matter and energy can warp both space and time. In areas of very strong gravity, like near a massive object, time passes more slowly compared to regions of weaker gravity. As the universe continues to expand and evolve, these variations in gravitational forces impact not only how space stretches, but also how time experiences shifts depending on where one is located within that vast expanse. Thus, while we perceive time as a constant flow in our everyday lives, the universe's expansion reminds us that time can be influenced by the cosmic fabric, altering our connections to the past, present, and future throughout the universe. Myths and legends have always sought to explain the mysteries of time in ways that resonate with human experience. Many cultures viewed time as cyclical, where events repeat themselves in a continuous loop. This perspective is often illustrated through the stories of creation and destruction, like how seasons change or how life follows a birth, growth, and death cycle. For instance, in Hindu mythology, the concept of cycles called yugas describes sweeping ages of creation and destruction, suggesting that time is an endless rhythm rather than a linear path. In contrast, other myths depict time as a linear journey, moving from a beginning to an eventual end. The ancient Greeks, for example, personified time as a figure called Kronos, representing time's relentless march forward, leading to change and decay. Such narratives explore themes of fate and destiny, giving time a sense of power over individual lives. Some legends incorporate the idea of time dilation, where beings might experience time differently. In Welsh mythology, the story of the hidden land of Tir na Nog portrays a place where time does not function as it does in the mortal realm, allowing travelers to return home many years later, unaware of the passage of time. This explores the intriguing notion that time can stretch and compress based on circumstances, a concept that resonates with modern understandings of relativity in physics. Ultimately, myths and legends reflect humanity's deep fascination with time. They embody our struggles to understand not just the mechanics of time, but also its impact on our lives, the world, and our place in the universe. These stories capture the essence of time's complexity, weaving together existential insights with cultural values, all while inviting us to ponder our relationship with this elusive dimension. Cultural icons and figures can serve as powerful representations of time within storytelling, often embodying the passage of eras or significant changes in society. Think of characters like the wise old sage in many myths, representing knowledge accumulated over lifetimes. This figure illustrates the importance of history and experience, showing how past lessons influence the present and future. In contrast, youthful protagonists often symbolize hope and potential, highlighting the dawn of new ideas and change. Their journeys resonate with the idea of progress, capturing the essence of time as a forward-moving force filled with possibilities. Narratives featuring these characters frequently reflect societal shifts, moving from the old ways of doing things to innovative paths that reshape communities. Moreover, time travel stories utilize these icons effectively by allowing characters to interact with different time periods. This gives audiences the unique perspective of witnessing how actions in the past impact the future, revealing the interconnectedness of different eras. Characters who bridge these timelines often embody contradictions, merging past traditions with modern ideals. In various traditions, figures like the Grim Reaper symbolize the inevitability of time's passage, reminding audiences that all things come to an end. These representations encapsulate human fears and acceptance regarding mortality, positioning time as a pivotal theme in life's narrative. Ultimately, cultural icons serve not only to reflect time's journey, but also to instill deeper meanings about existence, change, and the legacy each generation leaves behind. Through their stories, they weave a tapestry of human experience that bridges the past, present, and future, inviting audiences to reflect on their own relationship with time. Indigenous cultures around the world often present unique perspectives on time that challenge the conventional linear understanding prevalent in many modern societies. Instead of seeing time as a straight path from the past to the future, many indigenous beliefs emphasize the cyclical nature of time. For example, in various Native American traditions, time is viewed as a wheel, where past, present, and future are interconnected. This perspective suggests that events and experiences are not isolated, but instead resonate and influence one another across generations. Stories from these cultures often highlight the importance of seasons and natural cycles, illustrating how time is intertwined with the environment. The rhythms of nature serve as a guide, illustrating that time is marked by growth, harvest, and the changing states of the natural world, rather than mere ticking clocks. For instance, some indigenous peoples believe that significant events can resonate more strongly during certain times of the year, creating a sense of continuity with ancestors. Moreover, many Aboriginal cultures in Australia emphasize dream time, a concept that blends creation stories with the representation of time. In this view, ancestral beings created the land and its laws during the dream time, which is not confined by linear progression. Instead, it is an eternal moment where past events are still active and relevant today. This notion fosters a sense of belonging and responsibility towards the land that transcends conventional timelines. Through these rich traditions, we see a profound understanding of time that underscores connection, continuity, and the importance of living harmoniously with the cycles of nature. These insights invite us to reconsider how we relate to time, encouraging a more holistic approach that honors history, respects the environment, and acknowledges the interconnectedness of all life. Ancient tales have long been fascinated with the concept of time, often portraying it as a fluid and complex force rather than a simple measurement of past, present, and future. Many cultures imagined time as a circular journey, where past events influence the present and actions resonate into the future. This perspective mirrors some modern scientific discoveries, particularly in the realm of physics. When we explore the theories of time in contemporary science, we find ideas that echo those ancient beliefs. For example, in the realm of relativity, time is not a constant, but is affected by gravity and motion. This concept suggests that two individuals can experience time differently based on their circumstances. Similarly, in ancient narratives, characters often found themselves in situations where time was altered, where they might travel to different eras or experience time in a non-linear fashion, reflecting a deep understanding of time's elusive nature. Additionally, many ancient cultures spoke of time as being cyclical, with seasons and astronomical events repeating in patterns. Modern astronomy has revealed that the universe itself behaves in cycles, with galaxies, stars, and planets moving through vast periods that can be likened to the cyclical stories of old. The rhythm of celestial bodies resonates with time's natural patterns noted by our ancestors. Furthermore, concepts like time travel, often found in folklore, parallel scientific inquiries into wormholes and the potential for bending space-time. While these modern theories delve into mathematical and physical exploration, they reflect ancient peoples' longing for understanding the mysteries of existence. Thus, there exists a fascinating link between the mythological tales of past civilizations and the scientific investigations of today. Both seek to unravel the complexities of time, illustrating our continuous quest to comprehend the universe and our place within it. The ancient stories remind us that while our tools for understanding may have evolved, the essence of our curiosity about time remains timeless. Mythological interpretations of time bring a unique lens through which we can explore scientific concepts. Throughout history, different cultures have crafted stories that reflect their understanding of time, often presenting it as a fluid, cyclical entity rather than a strictly linear progression. For instance, in many ancient traditions, time is depicted as a wheel that turns, suggesting that past, present, and future are interconnected and can influence one another. This idea resonates with certain scientific theories, particularly those suggesting time may not flow in a straightforward manner. By integrating mythology with scientific language, we can make complex ideas more relatable. For example, the notion of time as a river, where experiences can flow back or forth, mirrors some of the theories in modern physics regarding the fabric of spacetime. Such creative interpretations can evoke curiosity and provide metaphors that help people grasp principles like time dilation found near massive objects or during extreme acceleration. Additionally, mythological stories often embody profound human experiences related to time, memories, aging, and the cycles of nature. This connection strikes a chord with the audience, facilitating deeper engagement with scientific discourse. When the ongoing debate about time's nature is framed within these narratives, it highlights the broad spectrum of how human beings perceive and relate to time across cultures and epochs. Mythological interpretations not only enrich scientific narratives, but also open pathways for conversation, making abstract concepts tangible and encouraging a diverse audience to explore the intricacies of time beyond calculations or theories. This combination encourages a holistic understanding, merging the logical with the mythical to foster both wonder and knowledge. Theories about the directionality of time, often referred to as the arrow of time, raise intriguing questions about the nature of reality itself. At its core, this concept examines why time seems to move in one direction, forward rather than backward. One of the primary theories supporting this is based on the idea of entropy. Entropy is a measure of disorder within a system. In simple terms, things naturally progress from an ordered state to a disordered one. Imagine stacking a set of blocks neatly. Over time and with enough disturbance, those blocks will fall into disarray. This increasing disorder helps explain why we perceive time moving forward. As systems evolve, they tend toward greater chaos, marking a clear direction. Another perspective comes from the theory of relativity, which treats time as intertwined with space into a four-dimensional fabric known as spacetime. According to this view, time can behave differently under various conditions, like moving quickly or being close to massive objects. While relativity allows for the fascinating idea of traveling through time or experiencing it differently, it doesn't fundamentally alter the flow from past to future. Instead, it supports the notion that our experience of time is very much tied to the physical properties of the universe. Furthermore, our psychological perception of time influences our understanding. Humans remember the past and anticipate the future. This cognitive framework shapes our reality, reinforcing the idea that time flows forward based on our experiences, while theories about time's directionality help us explore the fundamental workings of the universe. They also challenge us to consider deeper questions about existence and our place within it. Are time and reality intertwined, or is our understanding simply a reflection of our experiences? The interplay between these theories and our lived experiences opens a fascinating dialogue about the nature of time itself, urging us to explore not just what time is, but also how we perceive it. The thermodynamic arrow of time is a concept that explains how time seems to flow in one direction, from the past toward the future, and it is closely tied to the idea of disorder and energy exchange. Imagine a room filled with a mix of clean and dirty dishes. Over time, if we do nothing, the mess tends to increase. This mirrors the second law of thermodynamics, which states that energy systems naturally progress toward a state of greater disorder or entropy. In simple terms, entropy is a measure of how piled up or dispersed energy is in a system. When we observe everyday events like ice melting into water or a cup of coffee cooling down, we see that they lead to more disorder. The ice cube melts and mixes with the warmer water, creating a new state. This increase in disorder provides a clear direction, suggesting that the future is defined by a rise in entropy. While time on a clock ticks forward, the thermodynamic arrow emphasizes that the universe also evolves in such a way that systems become more disorganized as time passes. Essentially, we experience time moving forward as we witness these changes in entropy, which makes the arrow of time not just an abstract idea, but a very real part of our everyday experiences and observations in the universe. Reversibility and entropy play crucial roles in how scientists understand time. To start, imagine time as a flowing river. In this scenario, reversibility refers to the idea that, under certain conditions, events in this river could flow both forward and backward without consequence. For example, if you were to watch a movie of a cup falling and breaking, you could imagine how that scene might play out in reverse, with the pieces floating back together. This concept of reversibility can be found in many fundamental laws of physics, like those governing motion and energy. However, the real world is a bit more complex, primarily due to entropy. Entropy is a measure of disorder or randomness in a system. When we observe natural processes, we see that they tend to move towards greater disorder over time. Think of it like a child's room. If it starts out clean and organized, over time it tends to get messier without anyone actively cleaning it up. In the universe, this means that as systems evolve, they move from states of lower entropy, where everything is orderly, to states of higher entropy, where disorder reigns. Now, when we combine these two concepts, we see a fascinating relationship between time and entropy. The arrow of time, which indicates that time moves in one direction, aligns with the tendency for entropy to increase. This means that while some physical processes can theoretically reverse, the overall trend of entropy moving towards disorder marks a clear direction for time. In scientific models, this relationship helps explain why we perceive time as flowing only forward. It gives us a natural boundary that connects the passage of time with real, observed processes in our universe. Simply put, while some aspects of physics allow for the idea of reversing events, the overarching influence of rising entropy shapes our understanding of time as having a definite path toward the future. Reversing time, while a fascinating concept, would fundamentally challenge our understanding of events and causality. Imagine a film that plays backward. Instead of witnessing events unfold, you would see them reverse. If this were possible in reality, everything we know about history would be subject to reinterpretation. In our current understanding, events happen in a linear progression where causes lead to effects. If we could go back in time, we might see decisions made and paths taken that shaped the world as we know it. This could provide insights into how certain critical moments occurred. However, it raises complex questions about change and choice. If we alter a past event even slightly, the ripple effect could transform the present and future in unexpected ways. Additionally, this would challenge the idea of historical truth. A historical narrative is built on evidence, witness testimony, and interpretation of events. If we could view these moments again or change them, we would need to reevaluate what we consider factual history. Governments, cultures, and societies might argue over interpretations of their pasts, leading to conflicts about identity and legacy. As for the future, the ability to see what could be is also intriguing. If we could observe potential futures, we might better prepare for upcoming challenges. However, knowing the future could also lead to a sense of inevitability, potentially paradoxical experiences where knowledge itself influences events, much like a self-fulfilling prophecy. If we could reverse time, we wouldn't just be looking at what has happened, but at what it means for our identities and destinies. It would open a powerful conversation about fate, free will, and the interconnectedness of all events in the tapestry of time. Time, a fundamental aspect of our universe, seems to move in a single direction, from the past into the future. This phenomenon is often referred to as the arrow of time. Scientists have long contemplated why time behaves this way, and it involves a mix of concepts from physics and philosophy. One key idea relates to the second law of thermodynamics, which states that in any closed system, things tend to move toward a state of disorder or randomness over time. Think of a box of mixed-up toys. If you leave it alone, it won't spontaneously organize itself. Instead, it gets messier. This inclination towards disorder provides a clear directionality to time. As systems evolve, they tend to move from organized states to disordered ones, marking a distinguishable difference between past and future. Another fascinating aspect involves the role of human perception. Our brains are wired to remember past experiences while anticipating future possibilities. We create a timeline of memories, which further solidifies the sense that time marches forward. When we observe events, we tend to see cause and effect. An action leads to a reaction, reinforcing the linear progression of time. Moreover, theories regarding the fabric of space-time suggest that while the equations of physics allow for time to flow in both directions, our experiences are bounded by the conditions of our universe. For instance, if we were to consider particles moving backward in time, it would conflict with our everyday observations of reality. As scientists delve deeper into the nature of time, they explore profound questions through experiments, such as observing the behavior of particles in high-energy environments. These studies help us unravel the complexities of time's flow. Ultimately, the mystery of why time has a one-way flow remains one of the most intriguing puzzles in both physics and philosophy. Each discovery adds a layer to our understanding, drawing us closer to deciphering this enigmatic dimension of existence. Advancements in our understanding of time could lead to profound changes in future societies. Think about how we perceive and measure time today, mainly through clocks and calendars, marking hours, days, and years. But what if we delve deeper into the very fabric of time itself? Imagine the possibility of manipulating time, much like we handle energy or resources. If scientists were able to harness insights from theories of time, we could unlock new technologies that may revolutionize travel, communication, and even our daily lives. For example, if we discover ways to alter how time flows, or even create environments where time behaves differently, it could lead to new kinds of transportation. Traveling vast distances might not seem so daunting if we found ways to speed up or slow down our perception of time. Additionally, this enhanced understanding could reshape our approach to health and aging. If we learn more about the biological processes tied to time, we might develop methods to slow down the aging process or improve mental health. People could experience longer, healthier lives, gaining more time to explore knowledge, creativity, and relationships. In economics and productivity, a deeper comprehension of time's nature might shift how we organize work and leisure. With insights into efficient time management, societies could create environments that prioritize well-being, enabling people to live fulfilling lives rather than strictly adhering to traditional work hours. On a philosophical level, exploring the essence of time could revolutionize how we think about our existence. It could prompt discussions on fate, free will, and the interconnectedness of past, present, and future. Such reflections could foster greater understanding among cultures and individuals, promoting a sense of unity. Advancements in understanding time have the potential to transform society on numerous levels, from technology and health to economic structures and philosophical beliefs. As we push the boundaries of knowledge, we may create a future where our relationship with time is completely redefined, opening up endless possibilities for progress and fulfillment. Redefining our understanding of time could unveil a remarkable array of unforeseen technologies. At the heart of these advancements lies the ability to manipulate time in ways never before imagined. One possibility involves time perception enhancement. Imagine devices that could allow us to experience time more slowly or quickly, potentially extending our productive hours, or even giving us moments of reflection that seem longer than they are. Another intriguing potential is in the realm of communication. If we could alter our perception of time, we might develop technologies that enable real-time interactions across vast distances, making it feel as if we are in the same room with someone who is light years away. Such innovations could transform how we connect, breaking down barriers imposed by traditional limitations. Additionally, the medical field might benefit significantly from a new grasp of time. Think about technologies that could slow cellular aging or boost the healing process by manipulating biological time. Treatments could be developed that make patients feel as though they are recovering at an accelerated pace, potentially altering the future of medicine itself. Moreover, we could envision energy systems that tap into time itself, optimizing the flow of energy to match our needs moment to moment. This could lead to the development of incredibly efficient renewable energy solutions that adapt to usage patterns in real time, revolutionizing how we harness and consume energy. Finally, a profound shift in our perception of time could also influence artificial intelligence. By reprogramming AI systems to operate on a different timescale, we might create machines capable of complex problem-solving at speeds previously thought impossible, thus providing solutions for challenges in fields ranging from climate change to space exploration. Redefining time's reality opens up a vista of innovative technologies that could reshape communication, medicine, energy, and artificial intelligence, leading us into an era defined by unprecedented possibilities. Redefining time could fundamentally reshape how we perceive our lives and experiences. Imagine if our concept of time shifted from a linear progression, where moments tick away in a straight line, to something more fluid. This change might allow humans to experience life not just as a series of events, but as interconnected moments, where past, present, and future can blend more seamlessly. Such a transformation would impact evolution in profound ways. If we began to perceive our lives with a heightened sense of connectedness, our social structures might evolve to become more communal. This could foster collaboration and empathy in ways we haven't fully realized. Enhanced awareness could lead to a greater understanding of the consequences of our actions, urging us to make choices that benefit not just ourselves but future generations. Regarding consciousness, redefined time could enhance our cognitive abilities. An expanded perception might allow for deeper introspection and greater mindfulness. This enhanced state of awareness could lead to breakthroughs in creativity and problem-solving, allowing us to approach challenges with a broader perspective. With time experienced as a more fluid entity, we might discover new dimensions of thought, altering how we process experiences and shape our identities. In this scenario, the human experience would become richer, experiencing events with depth rather than just chronological order. Our connection with nature and the universe might deepen, making us more attuned to the rhythms of life around us. All these shifts would not only influence our personal journeys but also the collective evolution of humanity. Science fiction and speculative fiction often explore the idea that time can be fluid and even an illusion. In many of these worlds, time is not experienced in a straightforward manner. Characters may encounter scenarios where past, present, and future coexist simultaneously. Imagine a landscape where events from different timelines overlap like the layers of a painting, allowing beings to step in and out of moments as if they were turning the pages of a book. In such narratives, time can be depicted as a construct created by conscious beings. For instance, some stories portray civilizations that have discovered technology or methods to move beyond the usual constraints of time. This could manifest as people living their lives without a strict beginning or end, interacting with events at will, much like choosing a scene from a film to watch repeatedly. Moreover, authors often delve into the consequences of manipulating time. Characters may grapple with ethical questions, like whether changing the past can erase someone's existence or disrupt the future. This leads to thrilling storylines where the action takes place across different eras, challenging the characters' perceptions and leading to push and pull narratives that reflect both personal growth and cosmic implications. Another common element is the exploration of time within the human experience. Some works focus on how memories shape identity, suggesting that our perception of time is colored by emotional experiences. When time becomes an illusion, the characters might find themselves questioning the nature of reality, leading to profound philosophical reflections that resonate with audiences. In these imagined worlds, the very fabric of reality becomes a canvas for creativity, allowing storytellers to ignite the imagination and invite audiences to ponder deep questions about existence, consciousness, and the nature of time itself. Humanity's relationship with time could change dramatically as new discoveries unfold. Historically, we have viewed time as a constant, an unchanging backdrop against which events occur. However, with advancements in science, especially in fields like astrophysics and quantum mechanics, our understanding of time is becoming more fluid. Consider the implications of discovering that time might not flow at a uniform rate everywhere. Thanks to the theory of relativity, we already know that time moves differently based on the strength of gravity and speed. For example, if you were to spend time near a massive object, like a planet, and then return to a location with less gravity, you might find that far more time had passed for others than for you. This revelation challenges our basic perception of time as a singular experience, suggesting it can stretch and contract depending on our circumstances. If we could further harness this understanding, perhaps through technology or advanced space travel, humanity may be able to manipulate our own experiences of time. Imagine if we could adjust our pace of time, allowing for extended periods of learning or creating, while minimizing the burdens of aging or waiting. This could lead to new ways of living, making moments richer and more meaningful. Additionally, as we continue to explore deep space and understand concepts like black holes or cosmic events, we may discover entirely new aspects of time. These discoveries could unveil the interconnectedness of time across vast distances and timelines, possibly allowing humanity to rethink our place in the universe. As we make these discoveries, our relationship with time may evolve from a simple, linear experience to a more complex, multidimensional understanding. This evolution could profoundly influence our culture, philosophy, and even the way we measure success and fulfillment in life. Rather than being dominated by the clock, humanity might find a more harmonious coexistence with time, all shaped by the exciting explorations that lie ahead. The concept of time often feels linear, past, present, and future marching forward. However, when looking at certain scientific theories, such as those related to black holes or even quantum mechanics, time may appear more like a flexible construct than a strict timeline. This potential illusion of time challenges our traditional views and raises fascinating ethical questions. If we consider time as a more fluid possibility, it influences how we think about responsibility and choice. For instance, if actions in the past could be seen as merely one possibility in a vast array of outcomes, it complicates our understanding of accountability. If someone were to say, "What I did was just part of a timeline that could have turned out differently," how does that affect the way we judge their actions? Additionally, if we entertain the idea that future events might be influenced by changes in the present or past, ideas reminiscent of time travel theories, then we start to question the morality of our choices. Every decision we make could hold immense weight, not just for ourselves but for future generations. If we accept that what we do now has the power to alter the very fabric of time, it places a profound responsibility on our shoulders. This intersection of time and ethics invites us to reflect deeply on how we view our choices. Are they fixed, or are they part of a larger, more intricate pattern that transcends our immediate experience? This exploration encourages us to think about not only how we act in the moment, but also how those actions ripple through time, affecting those yet to come. By understanding time as a potentially illusory construct, we open the door to a more empathetic and responsible approach to our ethical considerations in life. Reconceptualizing time opens up a range of intriguing existential questions that challenge our fundamental understanding of life and existence. At its core, time is often viewed linearly, where events unfold from the past through the present into the future. When we shift this perspective, inviting ideas like time being cyclical or non-linear, it prompts us to ask, what does this mean for our understanding of life and death? If time is not a straight line, does that suggest the possibility of past lives or futures already predetermined? Another pressing question emerges around the nature of free will. If time can warp or loop in unexpected ways, are our choices genuinely our own, or are they predetermined by a timeline we cannot perceive? This notion can evoke anxiety as we ponder our role and the significance of our actions. Additionally, reconceptualizing time raises questions about the universe's nature. If time is relative, as physics suggests, what does that imply for our reality? Are there truths in the universe that remain elusive, existing outside our linear experience of time? In grappling with these ideas, we also confront the very nature of existence. Are we merely travelers through time, witnessing events unfold, or are we active participants in a greater cosmic dance where every moment holds significance? These questions invite us to reconsider our relationship with time, inviting a deeper reflection on our lives, our choices, and our place in the universe. Viewing humanity's place in the vastness of space can profoundly shape our thoughts about mortality and the concept of legacy. When we consider the enormity of the universe, with its countless stars and galaxies each containing their own stories, it can make our individual lives seem both small and incredibly significant at the same time. The knowledge that we exist on a tiny planet in a seemingly endless cosmos may drive us to reflect on the fleeting nature of life. Each moment becomes precious as we recognize the limited time we have to make our mark. At the same time, this perspective often inspires a desire to contribute to something greater than ourselves. The quest to explore and understand the universe ignites a flame of curiosity and ambition, prompting us to leave a meaningful legacy. Whether through scientific discovery, artistic expression, or acts of kindness, people may feel compelled to ensure that their existence resonates beyond their lifetime. This connection to the universe influences not just personal ambitions, but also collective aspirations, where humanity seeks to unite in exploration, knowledge, and the hope of surviving not just as individuals, but as a species. Ultimately, the exploration of space spurs questions about our purpose. It encourages us to reflect on what we want to achieve and how we want to be remembered. The vast unknown can ignite a sense of wonder about life itself and its significance, prompting us to cherish our time and strive to leave an imprint on the universe, however small it may seem amid the stars. As we explore the vastness of the universe, ideas about its nature can significantly impact how we view our place within it. The mere scale of the cosmos poses profound questions about purpose. For instance, when we contemplate the billions of galaxies, each filled with countless stars and potentially planets, it can make us feel both incredibly small and excessively vast at the same time. This duality challenges the notion that there must be a specific reason for our existence. When considering the possibility of extraterrestrial life, we are led to ponder whether our experiences are unique or part of a larger, interconnected tapestry. If life exists elsewhere, how does that redefine our significance? It could mean that we are simply one among many, which can diminish the feeling of having a destined role in a grand narrative. On the flip side, this expansive community of life may also suggest that our actions and choices contribute to a broader universe, giving us a part to play in an incredible collective journey. Furthermore, theories about the fate of the universe also provoke deep thoughts about destiny. For example, the potential for everything to end in entropy, where all matter and energy become evenly distributed and inactive, raises questions about the lasting nature of life and purpose. If everything will ultimately fade into an unchanging state, how do we reconcile that with our own search for meaning? These reflections compel us to look inward and question our values and motivations. Whether life has a predetermined purpose or not, each person's choices and experiences can create personal meaning. In this sense, while we may grapple with the enormity of the universe and its implications, the quest for understanding can itself become a deeply fulfilling journey, emphasizing exploration, connection, and the pursuit of knowledge as central to our human experience. Ultimately, as we confront these challenges, we may find that purpose is not just given, but something we actively create through our lives and relationships. Understanding that time can often feel like an illusion can profoundly change how we view our lives. When we think of time as a rigid line moving from the past to the future, we may feel overwhelmed by the pressure of deadlines and the rush of daily responsibilities. However, recognizing time as a more fluid concept allows us to see our experiences differently. Imagine moments in life that feel timeless, those instances filled with joy, love, or deep connection. In these moments, time seems to slow down, allowing us to fully engage and appreciate our surroundings. By embracing the idea that time is not simply ticking away, but rather a series of rich experiences, we can cultivate a deeper gratitude for each day. This shift in perspective encourages us to focus on the present rather than getting caught up in worries about what lies ahead or the weight of what has passed. By exploring this illusion of time, we become more aware of the fleeting nature of moments, leading us to savor them more. We might prioritize relationships and experiences that bring us happiness, realizing that these are what enrich our lives, not just the accumulation of time. This understanding fosters mindfulness, allowing us to slow down, breathe, and appreciate the beauty around us rather than racing through life. When we embrace time's illusion, we open ourselves up to a more profound appreciation of life itself. It helps us relish our journeys, fueling a deeper connection to our emotions and to those we love, making each moment count in a way that transcends the strict measures of time. Alternative theories of time challenge our traditional views and ignite intriguing discussions about its very nature. For a long time, we have thought of time as a linear path, flowing steadily from the past, through the present, and into the future. However, some thinkers propose different perspectives that reshape this understanding. One such idea posits that time might not be as absolute as we perceive it. Instead of a uniform experience that everyone shares, time could be more like a personal journey, deeply influenced by motion and gravity. In this view, time can stretch or compress, meaning your experience of it differs based on where you are or how fast you are moving. Another captivating theory suggests that time could be more like a dimension, similar to a landscape of rolling hills. Instead of simply moving through time, we may actually be navigating and choosing how we exist within different moments. This idea presents time not as a continuous flow, but as a collection of possibilities that we can explore. Some thinkers even venture into concepts where all moments in time, past, present, and future, exist simultaneously. This indicates that every decision we make or event that occurs is part of a bigger tapestry, woven together. Under these theories, time becomes more complex, allowing for paths that may lead to alternate outcomes depending on choices made along the way. These alternative theories are not just speculative. They push us to question our beliefs about reality and explore the unknown aspects of the universe. By redefining time, they inspire a deeper curiosity about how we perceive existence itself, offering us a glimpse into new realms of understanding that lie beyond our conventional frameworks. At the crossroads of science and philosophy, time presents a fascinating array of fringe ideas that challenge our conventional understanding. One such concept is the idea that time may not be a linear progression, as we often perceive it. Some philosophers propose that instead of flowing from the past to the future, all moments in time exist simultaneously, much like a landscape where all peaks and valleys can be seen at once. This perspective shifts the focus from time as a moving arrow to a more complex, multi-dimensional construct. Another intriguing thought is the notion that time might be an illusion created by human consciousness. Some theorists argue that as biological beings, we experience time through our perception and memory. In this view, past events exist only in our minds, and the future is a realm of possibilities rather than certainties. This raises profound questions about existence. If time is merely a construct of our awareness, what does that mean for our understanding of reality? There are also discussions regarding the potential for time travel. While scientific theories suggest that it could be theoretically possible through the manipulation of space-time or the existence of wormholes, this idea dives deep into philosophical implications. If we could travel back to past moments, would we alter events? Would those changes rip through the fabric of reality, creating new timelines? These questions blend scientific inquiry with philosophical debate, sparking discussions about causal relationships and the nature of free will. Lastly, some fringe ideas propose that time may be perceived differently in various contexts, such as at different scales of the universe or under extreme gravitational forces. For instance, close to massive objects like black holes, time behaves differently compared to regions in space where gravity is weaker. This invites contemplation about how our experience of time is not just a personal matter, but also influenced by the universe itself. These fringe ideas encourage us to think deeply about the role of time in our lives and challenge the simplicity of our everyday experience. By examining these intersections between science and philosophy, we open up possibilities for a richer, more nuanced understanding of our reality. Radical perspectives in scientific thought often challenge established norms and encourage new ways of thinking. When scientists question the very foundations of their knowledge, they open the door to innovative ideas and inventions. For instance, consider how the concept of a universe that expands, once deemed radical, has now become a cornerstone of modern astrophysics. This shift in perspective encouraged scientists to explore implications like dark energy and the cosmic microwave background. Such bold ideas disrupt conventional thinking, prompting researchers to explore uncharted territories. When an established theory is questioned, it leads to further inquiry and experimentation. This process can spark breakthroughs that radically alter our understanding of the universe. For example, the radical idea that life could exist in extreme conditions on other planets has spurred developments in astrobiology, leading to missions that search for life in environments once thought inhospitable. Moreover, radical perspectives often unite different scientific disciplines. They encourage collaboration by showing how ideas from one field can be applied to another, like using principles from physics to solve biological puzzles. This interdisciplinary approach can lead to innovations that would not be possible within the constraints of traditional thinking. Embracing radical perspectives fuels scientific inquiry, promotes collaboration, and encourages bold experimentation, all of which are essential for driving innovation in science. The willingness to explore the unknown can lead to the next big discovery, transforming how we understand our world and beyond. Exploring unconventional theories of time presents both fascinating opportunities and significant challenges. First, the rewards of venturing beyond traditional concepts can lead to groundbreaking discoveries. These innovative theories could reshape our understanding of the universe, provide insights into how gravity interacts with time, and possibly unveil connections between different realms of physics that remain unexplored. By challenging established views, scientists might even develop new technologies or better comprehend phenomena that occur at cosmic scales, such as black holes or the beginnings of the universe. However, diving into unconventional theories is not without risks. The speculative nature of some ideas can lead to confusion and misinterpretation, especially if they contradict well-established scientific principles. This can result in wasted resources, as researchers chase elusive concepts that lack a solid foundation. Additionally, unpopular theories might face skepticism from the scientific community, which can pose obstacles to gaining support for further research. Striking the right balance between creative exploration and rigorous scientific methodology is critical in ensuring that these unconventional ideas are tested thoroughly before reaching any conclusions. Ultimately, the journey into uncharted territories of time offers the potential for incredible advancements, but it is essential to proceed with a critical eye and an open mind, navigating both the exciting possibilities and the daunting uncertainties that lie ahead. Scientific communities must remain open-minded when it comes to redefining time through radical theories. Throughout history, science has evolved by embracing new ideas that challenge established norms. For instance, the transition from Newtonian physics, which described time as a constant, to Einstein's theory of relativity profoundly changed our understanding. Einstein proposed that time varies depending on speed and gravity, reshaping our perception of the universe. Being receptive to bold theories encourages innovation and the discovery of new possibilities. If researchers are too rigid, they may miss groundbreaking insights that could enhance our understanding of reality. Embracing fresh perspectives allows for the exploration of concepts like time travel, multiverse theories, and the interplay between time and space. However, this openness should be balanced with critical scrutiny. New ideas must be tested rigorously through observation and experimentation. In science, skepticism plays a vital role. It ensures that theories are robust and reliable. As we explore the nature of time, it is essential to welcome diverse viewpoints while upholding rigorous scientific methods. Ultimately, the quest to understand time continues to ignite curiosity and provoke thought. By blending openness to radical concepts with careful validation, scientific communities can foster an environment where revolutionary ideas can thrive, expanding our understanding of the universe and our place within it. Personal stories are powerful tools that illustrate the illusion of time in ways that resonate deeply with our experiences. Think of a moment in your life that seemed to stretch on endlessly, a day at the beach where every second was filled with laughter and joy, in stark contrast to a brief conversation that felt like it rushed by. These instances reveal how our perception of time is not solely dictated by minutes or hours, but instead influenced by our emotions, experiences, and states of mind. When people share their experiences like the joy of falling in love or the sorrow of loss, they often describe how time felt different in those moments. During extraordinary events, it's common to hear that time flew by, while during periods of waiting or unease, time appears to drag endlessly. These stories highlight that time is not just a rigid framework, but rather a flexible concept shaped by human experience. Moreover, the way we reminisce about past events can further illustrate this illusion. Some recollections are vividly clear, as if they just happened yesterday, while others fade into distant memories. This inconsistency in memory suggests that time is more about our mental processing than it is about a linear progression of events. Thus, personal stories offer compelling evidence for the illusion of time, allowing us to see how subjective experiences shape our understanding of this elusive and essential part of life. Time can often feel flexible, especially during unique life experiences that challenge our typical understanding of it. One of the most common scenarios occurs during intense moments of joy or excitement. Think about a day filled with laughter and happiness, where hours seem to fly by in an instant. In contrast, during moments of sadness or fear, even a few minutes can feel painfully prolonged, like an eternity stretching out. This difference in perception shows us how our emotions can bend our experience of time. Another fascinating instance arises with the routine and the mundane. When you're doing something familiar, like commuting to work or completing chores, the minutes can blur together, making the day seem to pass quickly. However, when you find yourself in a new environment or encountering something completely different, your brain takes in more information. Those same hours can feel fuller, creating memories that make time seem richer and even create the illusion that it's stretching. Moreover, consider experiences such as travel or extreme sports, where the thrill heightens your awareness. When you are fully engaged in the present, like while climbing a mountain or exploring a new city, your sense of time shifts as you savor every second. This expanded perception contrasts with how time is marked by the clock, showing us that our personal experience can reshape our understanding of time's flow. Lastly, age plays a role in this pliability. For children, each year feels like a significant portion of their lives, making time seem slower. As adults, each year appears to shrink, speeding up our overall perception. This difference in time perception from youth to adulthood is a powerful insight into how our relationship with time evolves through our life experiences. People often describe moments where time seems to stop or accelerate as profound experiences that feel outside the normal flow of life. Imagine a thrilling event, like a dramatic sports game or an intense moment in a conversation. In those instances, individuals might say that time feels like it has slowed down, allowing them to notice every detail, every emotion, and every sound around them. It's as if the world has paused, making everything more vivid and significant. On the other hand, there are moments when time appears to speed up, such as during a joyful holiday or a fun-filled day with friends. In these instances, people often express a sense of disbelief at how quickly the hours have passed. This feeling can stem from being fully engaged in something enjoyable, where the mind is so absorbed in the activity that it feels like time is racing away. These experiences can be explained by how our brains process information. During intense situations, the brain becomes highly active, collecting and storing memories in rich detail, often giving the sense of time slowing down. Conversely, during moments of routine or familiarity, the brain doesn't register time as deeply, leading to the subjective feeling that it has flown by. Thus, our perception of time is largely influenced by our mental engagement and the emotional weight of our experiences. Time is a fascinating concept that many people experience differently, leading to the idea that it might be elastic rather than rigid. Various subjective experiences can illustrate this. For example, think about moments of intense joy or excitement, like riding a thrilling roller coaster or celebrating a special occasion. In these instances, people often feel as though time flies by. The happiness and adrenaline can make seconds feel like mere instants, as if the clock is racing away. Conversely, during stressful or painful experiences, time can feel like it drags on endlessly. Picture sitting in a waiting room, filled with anxiety, anticipating news that could change everything. In such situations, minutes can feel like hours. This perception suggests that emotional states heavily influence how we experience the passage of time. Scientific research supports these subjective feelings. Studies show that when we are engaged or focused, such as while learning something new or experiencing novel events, time perception tends to speed up. In contrast, during monotonous or routine activities, the perceived passage of time slows down. Additionally, cultures can shape how people interpret and value time. Some cultures view time as flexible, where the focus is on relationships over strict schedules. Others prioritize punctuality and structure. These cultural differences reflect how elastic the perception of time can be, varying based on context and individual experiences. Our feelings about time can stretch or compress based on our emotional experiences and the cultural framework we live in. This fascinating interplay helps us understand that time is not just a ticking clock, but also a deeply personal experience. Testimonials from interviewees about time can have a profound impact on how viewers perceive its nature. When individuals share their personal experiences with time, whether it's feelings of urgency, moments that seem to stand still, or reflections on how time changes as we age, they bring a human element to this abstract concept. These stories allow viewers to relate to the intricate ways time intersects with life experiences. For instance, someone may describe a cherished moment that felt fleeting, emphasizing how that particular point in time became etched in memory, highlighting the subjective passage of time. In contrast, another might recount a challenging period that felt endless. Such contrasting perspectives can provoke viewers to reflect on their own relationships with time, enhancing their understanding that while time is a constant measurement, its significance can vary dramatically for each person. Moreover, these testimonials can evoke emotions and create a shared connection among viewers, deepening their engagement with the documentary. When different individuals articulate how time has impacted their personal journeys, it emphasizes the idea that time is not merely a fixed progression, but an experience shaped by context, memory, and emotion. This makes the subject relatable and invites viewers to contemplate their perceptions, leading to a richer and more nuanced understanding of time in their own lives. Interdisciplinary research combines insights from various fields to tackle complex questions, and the study of time is a prime example of this collaborative approach. Different disciplines such as physics, philosophy, neuroscience, and even psychology provide unique perspectives on what time is and how it functions. In physics, time is often defined by the way it interacts with space and matter. The theories of relativity illustrate how time can stretch and compress depending on speed and gravity, fundamentally altering our understanding of how time works in the universe. On the other hand, philosophy challenges us to ponder the nature of time itself. What does it mean for something to exist in time? Is time an absolute entity, or is it dependent on observation? This philosophical inquiry pushes the boundaries of our scientific understanding. Neuroscience contributes by studying how our brains perceive time. Research in this area shows that our experience of time can be highly subjective, affected by emotions, attention, and even cultural backgrounds. This understanding of subjective time perception can help bridge gaps between scientific and human experience, indicating that time is not just a linear path but also a complex lived phenomenon. When these fields collaborate, they create a richer and more nuanced portrayal of time. For instance, by exploring how humans cognitively interpret time against the backdrop of its physical properties, researchers can develop new theories that encompass both the scientific and experiential dimensions of time. This kind of research helps us not only to quantify time but to appreciate its effects on our lives, leaving us with a deeper understanding of both the universe and ourselves. Art and science often join forces in unique ways to explore the complexities of time. Science seeks to understand time through observation, experimentation, and data, while art interprets human experience, emotions, and the abstract nature of time itself. Together, they create a richer understanding of this elusive concept. In visual arts, artists use various techniques to represent time's passage. A painting may capture a moment, inviting viewers to reflect on what has occurred before or what will happen after. These visual narratives can express feelings about change, loss, and memory, resonating on a personal level. For example, Impressionist painters may depict the fleeting qualities of light and movement, evoking the transient nature of time. Science, on the other hand, unravels time through physics and cosmology. It investigates how time operates at different scales, from the ticking of a clock to the vast ages of galaxies. Concepts like time dilation reveal how time can move differently depending on speed and gravity, challenging our intuitive understanding of how time should flow. The collaboration between art and science also leads to innovative projects and exhibitions that engage the public. Installations might combine scientific data about time with artistic representations, encouraging people to experience and think about time in new ways. For instance, interactive exhibits can allow visitors to manipulate visual elements representing time, fostering a hands-on understanding of complex ideas. By merging artistic expression with scientific inquiry, we gain a more nuanced appreciation of time. This partnership invites us to explore not just the mechanisms of time, but also its emotional and philosophical implications, making the invisible forces that drive our lives more tangible and relatable. Literary analysis provides a unique lens through which to examine the concept of time, illuminating how different cultures and narratives understand this fundamental aspect of existence. Through stories, essays, and poetry, writers explore time not only as a linear progression, but also as a complex tapestry of memory, experience, and expectation. By analyzing how authors manipulate time within their works, we can gain insight into the human perception of temporal realities. For instance, in literature, time can be shown as fluid, where characters experience past, present, and future simultaneously, or where the passage of time feels slow or swift, depending on their emotions or circumstances. This subjective experience of time can enhance our understanding of scientific theories about time, such as relativity, which suggests that time is not constant but varies depending on speed and gravity. Moreover, literary narratives often reflect societal attitudes toward time, how different communities prioritize the past versus future, or how moments of change can alter the perception of time altogether. By integrating these literary perspectives with scientific inquiry, we create a richer dialogue that encourages us to think beyond just mathematical models and tangible measurements. This interdisciplinary approach can help bridge the gap between objective scientific understanding and the deeply personal, often philosophical interpretations of time that literature explores. Ultimately, by combining literary analysis with scientific discourse, we not only deepen our understanding of time as a physical phenomenon, but also appreciate its significance in our lives, stories, and cultures. This synergy fosters a broader appreciation for both realms, revealing that time is not just a scientific measurement, but a profound element of human experience. Exploring time through cross-disciplinary approaches opens up fascinating perspectives that deepen our understanding. Different fields, like physics, philosophy, psychology, and even art, examine time in unique ways. In physics, time is often viewed as a dimension, closely linked to space in what is called spacetime. This perspective allows scientists to analyze time as part of the fabric of the universe, influencing movement and gravity. Philosophy, on the other hand, invites us to ponder the nature of time itself. Philosophers ask questions about whether time is real or merely a concept of human perception. This exploration leads to discussions on whether the past, present, and future exist simultaneously, or if they are merely constructs of our minds. Psychology connects to time through human experience. It studies how we perceive time passing, like how time flies when we're having fun versus dragging on during dull moments. This insight reveals that our emotional states can alter our sense of time, adding a personal layer to the concept. Art brings a further dimension by using time as a narrative tool. Artists often explore themes of time through various media, portraying how moments can be captured or expressed in different ways. For instance, a painting may freeze a specific instant forever, while a video can show the passage of time in motion, provoking thought about change, continuity, and memory. Each of these disciplines contributes unique insights, creating a more complex and rich understanding of time. When we weave these perspectives together, we see that time is not just a straightforward sequence of events, but a multifaceted phenomenon that affects and is affected by our existence, thoughts, and creativity. This interconnectedness enhances our comprehension of time, making it a more engaging and profound topic to explore. Exploring the concept of time within a broad intellectual framework offers numerous benefits that enhance our understanding of both time itself and its implications across various fields. First, it encourages a holistic view. When we analyze time not just as a measurement, but as a fundamental aspect of existence, we can connect insights from physics, philosophy, biology, and other disciplines. This multidimensional approach fosters deeper inquiry into how time influences everything from the universe's creation to human behavior. Moreover, situating time within a wider context invites interdisciplinary collaboration. Scientists, philosophers, historians, and artists can come together to share perspectives, leading to innovative ideas and solutions to complex problems. This collaboration can illuminate various cultural interpretations of time, which may inform how societies structure their daily lives, celebrate milestones, or understand their place in the universe. Additionally, acknowledging the nuances of time can enhance our grasp of concepts such as change, memory, and consciousness. In psychology, for example, how we perceive time can affect our mental health and how we define our identities over time. Understanding these connections can lead to better emotional and cognitive support systems. Finally, examining time through an expansive lens can inspire curiosity and wonder. When students and scholars learn about time as a concept that intersects many realms of inquiry, it ignites a passion for discovery and encourages lifelong learning. This broad intellectual framework not only enriches our grasp of time, but also fosters critical thinking and creativity, essential tools in addressing the challenges of an ever-evolving world.